All right. Test 3 review. We are recording, and we can get started wherever anybody wants to get started, even if we've already done the problem. No judgment. If you didn't understand one, we'll redo it. What's up? That's okay. Totally okay. No. Don't say that. Hang on. I got to add some. Hey. Oh, this has all the stuff with it. Oh, no. That's okay. Okay, you said 2B. 2B. All right, let's grab it. I'm going to grab all of them because once we do one, it's not too tough to do the other ones real quick. And then actually I might throw off a little side note on this type of problem, which is the plussing thing, the plussing rule. All right, so find the degree measure that corresponds to the radian measure.
Skateboard?
Nice.
I didn't bring my skateboard sometime.
Me too. We can all go skateboard together after class.
I have a skateboard at home, but I haven't ridden in a while. So, basically, the last time I rode my skateboard, I was wearing knee pads and everything.
Nice. I have one of those one wheels. You know, the battery powered big wheel in the middle, sideways one. Dude, they're very fun. Dangerous, but fun. I have a 20. Yeah, no, I've eaten crap going 20 on a sidewalk, and I have a scar on my shoulder from it. It was unpleasant. All right, you said B? Okay. So this is degrees. This is radians to degrees. So radians to degrees, just in case you forget. I know some of us have it memorized, some of us don't. Just in case you forget, if you're ever thinking about it, just write the word radians, right? Because that's what you have. So look, negative 1.3 radians. That's what you have. Now, how do you cancel out anything? You want it on the top and the bottom, right? So you know what we're going to put on the bottom?
Pi.
Well, before I even write pi, I'm going to put radians, right? And you know what I'm going to put on the top? The little degree symbol. So you don't have to memorize which one goes top bottom, because now you know, right? What number goes with which one of those two things?
Oh, but this looks like a calculator one.
It would be. Yeah, it would. Or I would say just write it exactly as you think it should be. So this would be 180 over pi, right?
Yeah.
And so you multiply the things on the top and divide the things on the bottom, and it just turns into, and I'm just going to leave it alone. I'm not going to be a hero. Negative 1.3 times 180 over pi degrees.
We're not even multiplying along.
No, I'll leave it. If it were on the calculator portion, you could. If not, you can circle that and call it a day. I'm okay with it. I'm okay with that. That's true. What happened to the radians? This is just an important note with this little notation, this dimensional analysis. What happened to the word radians? It canceled out, right?
But wouldn't the degrees be like a degree symbol?
Oh, sure. You can write that if you want to. Both would be full credit. I don't mind which way you do it. Cool? Not too great? Not too bad? Okay. Oh, no. Are you okay?
No.
Ah. That's not the answer I wanted to hear. 0. This is just for fun. How many degrees are in 0 radians?
That's easy.
Hey.
It's either 0 degrees or 360.
Oh, that's a good thought. It's 0 degrees, right? But if they don't give you a thing, it could have been 360, right? Or is there a generic way we could write this? Not that they didn't say the word all, so we're not expecting that. But if they did say the word all, is there a generic way to write that?
I did it 0 degrees / 360.
0, it wouldn't be plus 2 pi k for degrees. 360k.
Oh, yeah.
Because right?
Is that what we're supposed to write?
No. That's why I said it doesn't have the word all. You know how sometimes it says find all solutions? You know how sometimes it says with capital letters find all solutions? This doesn't. But I'm just saying if they did say that word all, there's that 2 pi k thing or the 360k.
Wait a minute.
Just a thought.
I just realized something.
What'd you realize?
There's two things.
Okay.
It's actually, look, they have one that says 0 radians and another one says 2 pi radians. So I guess you put 0 degrees on the 0 radians.
Agreed. And how many degrees on the 2 pi?
360.
Agreed.
Now the one that when it was doing to radians, I just put both because there was another one that said 360 degrees.
Sure thing. Sweet. All right. What else we got? We got all day. Number 6. What? Yeah, that's what I was going. I wasn't gonna say no. All right, number 6, and I will just post this entire long sheet of notes. Though I think it's already posted. I could. It's not.
No, it's not. Trust me, I looked.
Okay. Well, the video's posted.
The video's not where?
Is it the same place as always?
It's not. But we're missing like 7.4 and 7.5 on the website.
Ah, rats. Okay. Well, someone email me that then. It's so much easier to do when I'm sitting at home than when I'm here, or than when I'm. Email it. If something's missing, just email it to me. I have it. I just haven't aligned it perfect. All right. Today? What, a video? It was because my dad emailed me saying, "Hey, you posted a video." I'm like, okay.
Well, yeah, the video, I was there. I watched it.
Yeah.
What video?
And that was on like Sunday morning, Saturday night.
Maybe kind of refreshing.
Yeah, that's probably why. So let's just like think if you're just that was gross. If you're just doing this without knowing anything, let's just think about the things we do know. Because sometimes it's like, oh, I don't remember how to do each problem. Well, that's okay. You don't have to know how to do each problem. What do we know about quadrant 3? Just right off the bat, I'm not even looking at the rest of this stuff. Okay, well, where is it first? I'm going to do even simpler, but you're right. It's this one, right? Okay, and what do we know about the things? Don't say they're both, but you're right. Sine is negative. So the sine of theta is negative, and the cosine of theta is negative. These are just thoughts. I don't know that they're going to come in handy. They might not even apply. But this is just if you're trying to start from scratch and like, I don't know how to do this problem because I don't remember systems of doing things. So I'm just going to try. Okay. Well, they gave us a cosine. And we've done this before where if they give us something, you know what we can do? Well, yes, we could do that. But you know what we could do even more than... Oh, yeah. If they ever give us one thing, you know, like a main thing is to do what? No, dang it. Don't try to try. Yes, we're going to end up drawing a triangle. But before we do that. No, it's easy. It's this. If you ever get one thing, your goal before you even look at the problem should be to do this. What am I going to try to do? Find what? What is
Find all the cosines.
Find all the things. There's only 6 things. If they give you one, go find the rest of them. I don't care what this is. Ignore this. Because that could change, right? But you know what can't change? That table of 6 things. That's there, right? This is pointless. Who cares about this? Let's go find this thing. Okay, so we know the middle one, which is cosine of theta, right? Equals negative 1 over 5. So, that gives us an easy one.
What I tried doing was drew it like imagine a coordinate plane and I drew a triangle.
You drew this triangle right here?
Yes.
Boop, boop, boop. Love it.
And then I used.
Well, hang on. Let's get the easy one. Before we do that triangle, which I love, let's get the easy thing. There's one easy thing to get out of the way.
The reverse.
The reverse, which is called? No. Secant of theta better be? Careful. Negative 5 over 1.
I think the question was asking to find in a given expression you're supposed to solve.
Yeah, but like I said, I don't care about that. That could change. You know what can't change? These 6 things. These 6 things are the same for every problem. Now we got to figure out the triangle to get the sine. Well, cosine stands for adjacent over hypotenuse, right? Cosine is adjacent over hypotenuse. So the hypotenuse better be 5, and the adjacent side better be 1, positive or negative. Based on the quadrant, we said cosine is that way, right? So negative. Also, that makes sense because hypotenuses are never the negative one. Like, we never make the hypotenuse negative. I can't think of ever doing it. So now we just got to find that other thing. A squared plus B squared equals C squared. That's Pythag. So 1 plus 25 equals... Whoa, that was wrong. Yeah, 25 is the hypotenuse. I was just rushing. Plus B squared equals 25. which means root 24 is what you're looking for. And do we positive or negative?
It would be would that be a negative?
Why do you think negative?
Because it's because they're going down
Because-
the y-axis.
Because it's going down the y-axis, and sine kind of means y direction, right? And cosine kind of means x direction.
What I did was I went further on the square root of 24. I made it 4 times 6. and
Love it.
That got into negative 2 square root of 6.
Like that?
Yeah.
Love it. Okay, so that means our sine of theta better be negative 2 root 6 over 5, which means our cosecant better be 5 over negative 2 root 6. Last but not least, our tangent better be opposite over adjacent, so negative 2 root 6 over negative 1. The negatives turn into positives. Double. Yeah.
Couldn't we just?
No. Yeah.
When we write the tangent, couldn't we just do 2 square root 6 over 1 because that's what tangent.
Couldn't we just leave it as 2 square root 6 and you're done?
Yeah.
Yeah, 100%. Definitely. If you want to see that as 2 root 6, please. Which means the cotangent is
Cotangent.
1 over 2 root 6. Yeah? Which, yeah, if you want to turn into root 6 over 6, that would turn into root 6 over 12.
Actually.
If you're taking them,
you would
just if you're taking them
multiply- you would just multiply by the square root?
on top and bottom, which is technically multiplying by 1.
Okay, that means I kind of mixed up.
All right? Now, I know that's not what they were asking for, but that's just showing ourselves that we can find all 6 from nothing. But what they were asking for was tangent, cotangent. That's funny. Oh, I remember doing this one last week. This is just a funny, this is a funny ask right here. Why is that a funny ask? Well, they don't cancel, but they turn into every time, right? That's just funny. But let's show them turning into 1. We've got 2 root 6 over 1 times 1 over 2 root 6. Oh, look at that. And then what's cosecant on this case? Looks like
Negative. Isn't it negative 5 over 2 square root of 6?
indeed it is. I threw my negative on the bottom, but if you have it on top, it's the same exact thing. So we end up with 1 minus 5 over 2 root 6,
Or it can be 5 square root of 6.
which is 1 minus 5 root 6 over 12. Same thing. I would accept both.
Oh,
I would accept
I
both.
forgot the 1. Whoops.
Oh, the 1 minus is important. Or if you did 1 plus a negative, also okay. Like, I'm not counting off points for you putting your negative with the fraction instead of in the middle. Like, it's the same thing. If you would, you know what I'm saying? Like, if your brain would have done 1 plus and then you did negative, that's fine. I'm not taking off points for where you put your negative. You know what I'm saying? Now, if you leave off the negative sign completely, that changes the problem. But just unreducing radicals or getting a radical out of the bottom, which is something that you can do just to make your thing look prettier or to combine things. If you multiply, this is 1, right? So I'm just multiplying by 1. So that's 2 root 2 over 2 now. So in the case we just did, use that same concept, a little more ugly, and 5 over 2 root 6 times root 6 over root 6 is 5 root 6 over these two combine to be just 6. So you get 2 times 6. They don't combine to be 6. That's what the square root means. The opposite of a square root is a square. The square root of x times the square root of x is... Thank you. That's important. That's the definition of square root, actually. Like, there's no other reason for the square root to exist if that's not true. What's up?
So we keep it like 1 minus 5 over 2 6.
Yeah. That's why that box said that's okay. Next year I might not, but since we've been doing that all year, might as well. And just don't tell your teacher next year. Just say, oh yeah, we did it that way. What's up? You can't.
Oh, wait.
What are you saying?
I think it's 24 for the radicals thing, but 2 squared root of 6. Maybe.
Did I mess up?
No, it is
No, no.
24 of
it's 6 times 2, so that would be
Wait, I'm confused.
12.
I'm confused. I'm a,
How is it 24?
what?
How's it 24? It's like it's.
Oh, are you talking about this right here? Negative 24? Those two things are the same. We just reduced out a. I started building this thing. This is funny. Because of not because of y'all. Absolutely not because of y'all. But I started building this for next year. Where would it be? I don't even know where I put it. Where would I have put it? I don't know. Oh, maybe it's in notes. Nope, it's not in notes. Huh. Well, I don't know where it is. But I started building out a things that you should know in pre-cal before getting into pre-cal. Yeah, here it is. And that's a big part of it right there. That square root thing. This crap. Like, which is this is what the one we just did. That one. But I just built like I'm slowly building like hey, these are all the things that are the most common mistakes. Like these exponent rules, nobody knows them. And we never learned them in this class. They're from like I don't know which grade. But they're just easy to forget. Or like I don't know, random this right here. Multiplying, adding, subtracting, dividing fractions. Nobody likes it. We never taught it, but it's there. It happens all the time. So I'm going to build that and do like a little first day of school quiz. And be like, hey, I'm sorry, this is why this is going to be hard. Like, because you have to know these things that we're never going to teach. All right, what else we got?
So in the future, you're gonna give people a quiz to take on the first day.
Yeah,
but
not for a grade. What's up?
Can you try to do like one of the 32, 38? Because I need to like refresh.
Yes. Okay, let me see one. I think 33 looks the most like approachable. 33 looks like something that I've seen on tests and finals, and it's not too hard, but it's not too simple. 33, like honestly, if I'm looking at these, 33 and 34 look like the two that I'm like, yeah, those are common. So let's do them. We can do both of them. I'm gonna grab both of them.
Yeah, I don't.
Heck, 35 is pretty good too. Actually, 35 is pretty cool. No. We can try them all. We can do as many. We got all day. I'm gonna grab all three of these. You're right. They all are slightly different, but none of them are new. It's just like applying the same stuff in kind of weird ways. Okay. I really don't like that this is not proportion, and there's no way to change it. It's really frustrating to me. Like, look, now it's a little too wide, right? Okay. All right, what are we doing? Which one? 33? There's one formula for 33 that's important.
Oh, is it the two?
Yep. And this is one just to know. You see that sine of 2 theta? Just think 2SC. Turns into 2SC. 2 sine, cosine.
I have a question about that.
Yo.
Is that the same if it's like cosine?
No.
Okay, so what?
Cosine is cosine squared minus sine squared. And then if you want to work out cosine squared minus sine squared to only have one of the two things, you can plug in the other thing. So remember there were 3 formulas for the cosine squared minus sine squared thing?
Yeah.
If you look at cosine of 2, there were 3 formulas, but sine only had 1 formula. This is where those 3 came from. So I've decided I'm just memorizing this, and if I want to get one of the other ones, I'm just going to plug in 1 minus sine squared right here, or 1 minus cosine squared right there to get it unique. But sine is just 2 sine. I wish it was the same for cosine. Then it'd just be one memorized thing. Minus cosine theta. And this is where they try to trick you, but don't be tricked. You wouldn't get it wrong if these weren't sines and cosines. You would get it right if it was x's and y's. And I know because we did it last time. Or not this one, but one like it.
Wouldn't we move the cosine to the other side?
Wouldn't? See, that's the trick. That's the trick. They want you to do that.
Oh.
What is the... If you move that cosine, you're going to be tempted to cancel it, right? and we
Yeah,
can't,
we can't.
and we don't want to cancel it because that's ignoring something important. Those two things. What's that called?
Oh,
Yeah,
factor out.
it's like reverse distribution. The distributive property in reverse, right? And if you don't like the way you did it, go check by distributing. Literally just do the distributive property and check and see if it's right. And then you know it's good. It is literally, it's reverse distribution is what it is. It's recognizing something in common and undistributing it. So what if you take a cosine out of a cosine, what are you left with? 1, not 0, right? That's important. And if you make it a 0 and try to distribute, you're going to see you're not going to end up with the same thing. If you make it a 1 and you distribute, you get the same thing. Oh, shoot. That's a thing. This is a thing. What? No. I'm saying this is a thing from day 3 of class. Ignore the sines and cosines. This format of a thing is a thing from very, very beginning. Don't be. What is interesting about this? Okay, watch this. I'm going to do a very parallel thing. 2x, y minus y equals 0. Just for fun. And you factor out that y, right? And you get y, 2x minus 1 equals 0. Now what would you do? Set what? Don't say it. It's a bad word. Set both things equal to 0. Oh, what? I didn't hear him. What'd you say? What'd you say? Oh, yeah. Individually set them. I didn't hear you say it. You individually set them equal to 0 because of this time sign, right? The time sign is the only thing that does it. If it was a plus sign, it wouldn't do it. If it was a minus sign, it wouldn't do it. If it was a division sign, it wouldn't do it. The time sign is the only special thing we have in the world that says A, B equals 0 implies, that's what this kind of weird looking arrow means. What does that imply? Or what does that mean? You could think of the word means. Okay, A equals 0 or B equals 0 or both, which is not common, but I guess if you have x times x, they both equal 0 and they're equal to 0, like x squared. If both equal 0, that also implies that A equals B, which is kind of fun, but don't worry about that. You can just keep going with that. It's fun. So cosine theta equals 0, which means theta equals, this is unit circle knowledge. Start here.
It would definitely be like pi over 2.
And
3 pi over 2.
okay, wait. Let's do this smarter. Actually, did they tell us to restrict the domain or no? Or what did they say? They just said here's some stuff. Okay, so there's 2 different options of answers, right?
Wait, they did. They said from.
Oh, they did it at the top of the section, right?
From 0 to 2.
Okay, well, let's still think about it in terms of 2 different types of answers, okay? So in the red, and I'll do it in red for the other side too. In red, this is from 0 to 2 pi, not including 2 pi, usually. Because they don't want you to have to, the 0 and the 2 pi are the same technically, right? So they don't want you to have to pick. That's why they do it that way. That would be the answers for that. No, but there's another set of answers that would be all solutions. And what would that be? Theta equals plus and pi over 2. No, what? Thank you. 3 pi over 2 plus 2 pi k. That's
But they restrained.
They did. That's why. But I like just thinking in your brain just to prove to yourself that you know what you're doing. You don't just know how to answer one type of question. Yes. If it's no, it's just pi k. Yeah, because tangent has a domain or a cycle. Same with period wave. If you remember the period, t equals 2 pi over k, right? For sine and cosine. But t equals pi over k for tangent. That's because the period of tangent, the repeat cycle for tangent, is pi. The repeat cycle for sine and cosine is 2 pi. So then we got to do the other one, which would be 2 sine theta minus 1 equals 0, which means sine theta equals 1/2, which means theta equals these two. The two short ones, not these two, not the middle ones, the two short ones. Pi over 6 and 5 pi over 6. Unit circle knowledge. I'm sorry if I went fast on that. And then for the all solutions, you literally just take those and add 2 pi k. It's worth thinking about just so you don't, so we remember that we know how to do it. Not too bad. That's a very common type. The like 2-step problem. The first step was factoring it out, and the second step was setting it equal to 0. 5-steppers, probably not common. 2-step, 3-step problems, more possible.
Is that next one like similar?
It's 2 steps. They just really, the 34, so here, let's do 34 as well. The 34, the only thing they try to do is make you take the wrong step first. They're trying to make it more work, which you could still end up in the right answer if you made it more work for yourself, but don't. There's a really easy thing to do before you make more work for yourself. Yes. Yes. No, for real. You could rope this 5 into this cosine and be working with it all day long, or you could say, screw it. I want you out of there. Now you're just a number over there. Cosine of 2 theta equals 2 over 5. A lot of people did that with logs when we worked on logs, and the test of logs is trying to rope a thing that's in front of it into the log by making an exponent or something. And it's like, yeah, you can do that, and you'll end up in the right spot.
Wait, so if there's a number up there, we can always get it out.
What's the invisible sign?
Oh, you're asking?
Yeah, multiplication, right? What's the opposite of multiplication? Division, yeah. Could you try to rope in one of these formulas that has a number in front? Sure, but don't. This is... Okay, now what? Cosine 2 theta. The only one that I've memorized, because everything else I find from finding it, is cosine squared theta minus sine squared theta. Everything else I find by plugging in. I didn't memorize. Oh, now I have to actually plug it in. Y'all want to go with cosines or sines? I don't care. Cosines? Why? Any reason?
Because the problem started with the side.
Okay. Oh, that's fair. That's fair. Yeah, it didn't have sines to begin with. We introduced it. I don't know which one's easier, honestly. Neither are easier or harder. It's just, what do you prefer writing? So what am I replacing that sign with in big old parentheses? 1 minus cosine squared theta equals 2 over 5, which means we get cosine squared theta minus 1 minus cosine squared theta equals 2 over 5, which means we get net. Whoop, wait, no, that's wrong. That's wrong. Plus sign. So you get 2 cosine squared theta minus 1 equals 2 over 5. Now what? Plus the 1. So 2 cosine squared theta equals 7 over 5. Divide by 2. Cosine squared theta equals 7 over 10. Eat. You're welcome. Root it. Cosine theta better be plus or minus 7 over 10. Did they give us a, what's it called? What? Did they give us a restriction? Yeah, because it's in the same set, so it's probably 0 to 2 pi, just based on this problem. But did they give us a, what's it called? What's the thing called? Quadrant. Did they give us a quadrant? No. Often they would. They didn't here. So that's it. Do we know that? Is that a common thing?
What about the 2? So sometimes like the answer would not be in the unit.
Yeah. If it's not, it would probably be, no. On test 3, it'll be in the unit circle. On the final, part 2, there's a chance it's not in the unit circle. That's the calculator section. No, this would just be theta equals arc cosine of positive root 7 over 10 and arc cosine of negative root 7 over 10. Which, no, you don't have. You just plug it in. Yeah, that's fine. But it really is worth thinking once you get that number.
Where did the 2 go?
What 2?
That was in front of the cosine squared.
You tell me.
You divided it
Indeed. And then where did it go?
to the right, to the 7 over 10.
Right? Because what was it before? Yeah. So it went to the bottom because division puts it on the bottom. And that makes it 5 times 2 on the bottom. Right? That's just skipping this step right here. Keep, change, flip. 7 over 5. Change, flip. Equals 7 over 10.
Answer is either
What'd you say? Keep the top fraction. Change the big divide sign to it. I don't like keep, change, flip. If you're dividing, it goes on the bottom. If you're multiplying, it goes on the top. That's how I think of it. Like, the keep, change, flip is just if you're really struggling to see that.
Why did the cosine turn positive after the bracket?
Ooh. Oh. You're talking about right there? Because -1,
Okay.
right? It's like distributing that invisible -1 that was right there.
Yeah, that was
Yep. Distributive property. I swear, the pre-cal is easy. It's the non-pre-cal that is the screw-up part, like the distributive property. All right, what else we got?
We don't. But isn't isn't it square root of 7 over square root of 10?
Is that not what I wrote? Oh, what the heck? Yeah, that's what I have. I don't know why. Oh, because I was just thinking about typing, like calculator typing. That's why I was. Because when you hit the square root, it opens up parenthesis, and I would have just. That's what I would. Yeah, you're right. It's a big square root, not a small square root.
Can you write it just like cosine theta equals cosine minus?
No, do the arc cosine if you're writing this. Because it's going to ask you solve for theta. And so you want to be specific and saying, this is theta right here. I solved for it. 37? Heck yeah, I will. Find the exact... Ooh, this is such a good problem. This is cool. Because it's got some stuff in the middle of something that... that I cannot stress enough. If you see this type of problem, you should do something immediately. If you see, there's something about this problem that should like jump out of the page that says, I need to do something immediately. But what jumps out to tell you triangle? This and this, even if there's stuff in the middle, right? Even if there's stuff in the middle, seeing an inverse and a regular next to each other tells me I need to make a triangle. Okay. So tangent equals 9 over 40. Now, I don't know which direction my triangle is. It could be this. It could be this. It could be this. It could, you know what I'm saying. I'm just going to draw a normal triangle for now, and if we need to change it, we will. Because right now, I don't know for sure. Is this all it says? They don't give us any more info? Like above? Okay, cool. All right, so what does tangent stand for?
Opposite over adjacent.
So let's just fill that in real quick. And go find something. What are we going to go find? The hypotenuse, which is a big number now, I'm thinking. 40 squared is 1600. 9 squared is 81. So 1600 plus 81 is 1681. By golly, I don't want to do that. But if I had to... I'm guessing it's a nice fraction. It's 41? Really? Okay. Hopefully calculator version. Hopefully on the test in the calculator. If not, just go start here and start going up. Start at the bigger thing, go 41, 42, 43, and then you'll get it. Because it's not going to be too much crazier than that. Okay, but we don't want tangent. Because they gave us tangent. Yeah, the 2 is interesting, and we've seen stuff like it before, but not with the tangent there. It's gonna be an identity.
Then look that up. It says select.
Don't look it up. Think it out.
Does it double or the same?
Watch this. What if we take this whole thing right here and say, I don't know what that is, but you know what I can call it? U, X, theta. I don't care what you call it. Let's call it, I'll go with X. You said X. I'm going with X. So this is just the cosine of 2, and going back to red, X, right? Where X is that big ugly thing. Well, I know that turns into something, right? What does that turn into? Cosine squared, not of theta now, of what? Of this red box X, right? Minus sine squared of this ugly X. Oh, shoot. What is that ugly X pointing me to? This triangle. It's the whole point of these types of problems. So technically speaking, this is cosine squared of invert tan of 9 over 40 minus sine squared of invert tan of 9 over 40. But you don't need to know that because it's just going to point us to that triangle. And what is cosine on that triangle? Yeah. So we're going to go 9 over 41. But there's 2 of them, right? Because it's squared. Times 9 over 41 minus 40 over 41 times 40 over 41. You're done? I don't want to do that.
Are you gonna put one like this in this?
Not on the non-calculator part. Possibly the same type, but like for 3, 4, 5 triangle. But not that. Unless it was with the calculator. Well, I don't know. Maybe this simplifies. Wouldn't this be 81 minus 1600 over... Wait, that's not going to be a positive. That means we are in the wrong quadrant. Tangent was 9 over 40. Interesting. That's just going to be a negative number, which I don't love. But that's okay. Oh, holy moly. There's one mistake. I don't have to change much, but what's the mistake here? Big mistake. Tangent's good. Big mistake right here. I made. Because I went too fast. Doesn't change any numbers. Doesn't change anything. It's just a real big mistake. And it'd be good to notice because then you can know that you know what you're talking about.
It says, but I thought the sign is correct. It's supposed to be minus.
Right. But there's a big mistake here. Real big mistake I made because I went too fast. And I want us to look at it and try to find it.
I think I know what it is.
What?
So you
Yeah.
chose you put them in the wrong place. The cosine is supposed to be 40 over 41.
Because it stands for what?
Adjacent over hypotenuse.
And my angle's right here, right? And what's adjacent to that angle?
40.
Right. So I screwed up. I was just going real quick, and I flipped where the sine and the cosine should be. And sine stands for opposite over hypotenuse, and opposite is 9, right? Of this angle. So nothing really bad changed. It would literally just flip the sign, S-I-G-N, of the thing. So it turns it into 40 over 41 times 40 over 41 minus 9 over 41 times 9 over 41. And I saw that quicker because I saw the negative sign. I was like, this shouldn't be a negative sign. And so now I've got 1600 minus 81 over 41 squared, which I don't know. I'm leaving it there. Technically, I guess you could do the 1600 minus 81. That's like 1519. Yay?
Is this with a calculator?
Yeah, this 41 squared, I think so.
Yeah.
What?
It's actually supposed
Oh, we already know it. That's funny.
1519
Over.
41 squared is 1681.
Thank you. Call it a day.
And it doesn't simplify, right?
I don't know. If it does, I wouldn't count you wrong for not, especially on a test. Promise. I promise.
Okay, so every single one of these problems will be on the test? Like, not on the final exam, I'm talking about this test.
No, not every single problem will be on the test.
No, I mean, like, every single type of, like, problem. You know
No.
what I mean? No?
There's 40 problems here. That's insane. That'd be too long.
Oh. So, can you say?
No.
Can you not say how much it'll be based off?
No, but I can tell you I'm not changing the numbers this time. So
Wait, what?
I'm not going to change the numbers this time.
Oh, but it's gonna be the
Exactly the same. Except for no, I did find out. No, but I did find out today that like for these ones, because of no calculator, I might have to change that to a possible number, like 45 degrees or 30 degrees or 60 degrees. Likewise, these two might have to change to 30 and 60. Otherwise, you can't do them without a calculator.
But did you say like if it's like one that we can do without a calculator, we don't use the complicated stuff?
Yeah, no, you usually just solve. If you
Okay, then change those numbers.
you could just do like 30, 60, 90 triangles and 45, 45, 90 triangles. No, because there's a potential here for a 45 degree angle and it not to be 90. There's a potential for a 45 degree angle and a 32 and whatever's left. And it still follow this rule with sine of 45 because the first rule you would use would be a squared plus b squared minus ab sine theta. Well, now if this is 45, you get your sine theta, root 2 over 2, but you don't have to, but you still don't know this 32 degrees and whatever the leftover, like, there's still a spot where 45 helps you, but these aren't perfect.
Why can you use
What?
the a to make it close to c?
Okay, so like,
Why can't you use the what?
Like a squared b squared.
Because it's not a right triangle. Right, exactly.
you can only do that on right triangle.
But there are a good number of right triangles on the final. As I was looking through it, there's a good number of right triangles. So don't get confused in trying to do all the hard stuff when you get a right triangle and you can just do a squared plus b squared equals c squared.
Wait, so now
Like, that'd be great. What are you confused about?
I'm confused. Where do we use the one where it's like you had to like see which operation we're gonna use and then say like sine b over something? You know what I'm talking about?
You do that when you're solving a whole triangle, not just looking for x.
Oh, okay.
So when you're just looking for this x right here, that's opposite of a thing that you have, you do this whole thing where you go, and we've already done this, I'll just show you the setup. You go like 10 squared, or x squared equals 10 squared plus 12 squared minus 10 times, wait, is it 2?
I think there's a 2 in the front of it.
Wait.
Good catch. Good catch. As I was remembering them, I missed it. 2, 10, 12,
Oh, look at that.
sine, 48. What?
Isn't that cosine?
Yes. Good catch. That's to solve for x, right? But then, once you have that, then you go x over, well, you can do that, but actually you do sine of 48 over x better equal,
That's what I meant.
this is what that's what I was saying. This is, when you're just solving for x, you don't have to know all that. But if you were going to fill out the rest of the triangle, I would say, okay, let me find this angle right here, call it q, equals sine of q over, and then I go to the opposite of q to get my proportion, which is 10. And that would also equal, call this one z, sine of z over 12. There's that thing you were just talking about.
So when it
So-
comes to,
Mhm.
so when we're trying to find sides or angles in these triangles,
Mm-hmm.
that are not right triangles, we're supposed to use like
The log formula first, law of cosines, which you'll only have to use once. And then the law of sines, which is that slightly easier one. And then all you're going to do from there is do subtraction.
like can we look over part B on 12 so I can see what you mean?
Can we do a different one since we've done... Oh, B. No, we haven't done B before. Okay, yeah. Sorry, I was looking at C. Yeah, we can do B real quick.
Can we also do 28 and 29?
Absolutely. Let me do B. We'll take a break, and then actually we don't have to take a break if y'all don't want to.
Can we, like, yeah, can we at least take like maybe a short break probably at the least?
Yeah, let me do this problem real quick. I'm gonna do this problem because this one won't take very long. The reason this one won't take very long is because there's a thing that's jumping out of the page that will help us. I think it might not help us, but I think it'll help us. Should be jumping out of the page, screaming at you, saying, "Don't work too hard. I gave you something." Well, but what I'm saying is what? The missing angle shouldn't be hard to find. This should be jumping out of the page at us. How is that jumping out of the page?
Because you just have to add the known angles together.
Exactly.
And then you subtract that from 180.
Exactly. 59? Appreciate it. Okay. And now, well, we don't even need the hard thing, I don't think. Yeah. We can just say sine of 59. And what does that go over? Which one does 59 relate to? Boop. Perfect. 230. And what are we solving for in this specific problem? X. So we'll go sine of which of those two? Over X.
Oh, now I see.
And here would be an example of one where you just set it up and leave it and call it a day and not be a hero. You don't have a calculator. Don't be a hero. Set it up, solve for X, and be done. Cross multiply, right? And you get X sine 59 equals 230 sine 69. And then what?
Yeah, X equals 230 sine 69
Divided by?
divided by sine 59.
Love it. And don't be a hero. You're done. None of those are nice, easy solves. So sometimes you don't even need that long, hard formula. Sometimes you only need the proportion formula called the law of sines. Rarely you'll need one law of cosines. Never will you need more than one law of cosines because you have to have two sides to use it. So you found your third side. You're done.
You know what I noticed when I looked at HuskieNet about schedules coming up is that the first week of school nobody even meets on Monday.
We have Monday off the first week of school? Wait, that's super nice because I'm going on vacation that weekend.
That's just what.
Start recording. Back to it. If oh
Okay, can you give me that? I'm just wondering.
It's not weird. Oh wait, this is a formula that we didn't do. But we can go and look it up and do this because of the easiness of this thing, we can go look it up and do it, right?
But is that gonna be up to
Maybe. If it is, I'll give you the formula. So sine -4/5. Cosine, that means the cosine is. We could know this one without even drawing the triangle.
Cosine of what?
Yeah, it's got to be, right?
Oh, that's.
And it's in quadrant 3, which means it goes like this.
But we also know the other.
So negative and negative. So -3/5. If you don't like it, go do the whole 6 chart thing again. So tangent of theta over 2. Who's got notes out?
Wait, where are the
It's 1 is equal to.
Pythagorean theorem. Triangle.
It's equal to
Look, 5.
Oh, okay.
Sine is -4. What does that make that side? Probably -3.
It's equal to 1 minus cosine theta over sine theta, which is also equal to sine theta over 1.
Wait, what? Is this it right there? That's it?
And then
Really?
yeah, so it's like
Oh.
equal to sine.
It's a pretty easy one. Well, no, I don't need the second one. That's fine. That's really the formula right there?
Where do we get the one from?
Well, the 1 is on the cosine of it.
Oh, that is the formula. Now I remember. Thank you. That.
I guess one of them.
Shh. Okay, so
Well, what's the 1 minus cosine?
it's just from a formula. If it shows up on the test, I'll give it to you.
What's that equal to?
Tangent of a fraction with a 2 on the bottom.
Oh, 'cause that's what I was trying to remember. It was that included a 1.
So we go 1 minus negative 3 over 5.
Wait a minute. How is it that? Isn't tangent supposed to be opposite over adjacent?
Yes, but this is just a formula. I will give you this formula. He just pulled it up from the notes.
I remember you saying.
What?
We're using cosine instead of the tangent.
No. What?
Are we gonna need to know the sum and double angles by memory?
You're just asking questions.
That's
I remember you saying.
yes. Yes. That the board is good.
Oh, that's what we need to know.
Yes.
Oh,
That's what I'm saying. If this shows up on the test, I'll give you the formula.
may I just say?
Oh, or just learn the.
May I
or-
just say? I remember you saying this unit was gonna be really easy
It is very easy.
for you.
Negative 4 over 5. Do some math. 1 plus 3 over 5 is 8 over 5. Negative 4 over 5. Got 8 over 5 over negative 4 over 5. 5's cancel. You got negative 2. That's not too crazy. But the formula is a thing. It's just there. That formula for tangent of theta over 2, it's a thing. Could we go prove that formula? Potentially. I don't know how. It'd be fun. Sine over cosine, split it up. But then you need the sine over cosine identities. What? Okay. I'm not saying this again because this is the fourth person that's asked that. This is a formula. It's called the half angle identities formula. If it shows up on the test, I'll give you the formula. The tangent of theta equals this. That's where we got it from. We didn't make it up. It wasn't like common knowledge. It's a form. It's like a formula. Just like all these are random crappy formulas. That also is one. Okay. What else we got? That's not as good of one. I thought that was better because I saw the negative, but I forgot the
Off to the question.
what.
For your for your phone, do you take a selfie like folded or like?
I don't take selfie. So easy answer. All right, what are we thinking? 8. 8 looks like express tangent in terms of secant. That's kind of odd. Well, let's go see. Express tangent in terms of secant. So they're saying if you're given tangent, change it to be secant. Why on earth you would want to do that is beyond me. But the fact that we can do it is possible. So you're given tangent. What is tangent?
It's cosine over it's sine over cosine.
Tangent of theta is sine of theta over cosine of theta. Well, that still doesn't give us in terms of secant.
Well, we're supposed to.
Well, can we?
Rearrange the equation.
Yeah. Well, wait. One of those things goes to secant quickly. Cosine
Cosine goes to the secant.
cosine goes to secant pretty quick, right? Because technically, cosine of theta is
So the sine times tangent equals
1 over secant, which means secant is 1 over cosine, which means I can go tangent theta for now, though we still got to figure this sine thing out, is 1 over secant, right? Just for fun. Well, we still don't have tangent in terms of secant because we have the sine. Yeah, we can flip that, though. Keep, change, flip. Keep, top. Change, division to multiplication. Flip, bottom. You're done. That's your keep, change, flip. But we don't have tangent in terms of secant. We have tangent in terms of sine and secant. So we got to figure out a way to change sine to secant. We only have one formula that goes from sines to cosines, right? The squarey one. So what's that formula? Sine squared plus cosine squared equals 1. And which of these are we probably going to want to get by itself? In order to sub it into that form. In order to sub it in over here, No, you don't. You need to get sine by itself. Sub it in. Right?
Wait, I'm confused.
Why?
Because I thought so far we have sine beta times secant beta.
We do.
You can use them out a little bit.
Yes.
So why would we use
This formula?
that formula that's like the Pythagorean?
Because watch this. This is technically the same thing as sine squared of theta equals 1 minus cosine squared of theta, correct? Correct? Don't say now. That's right.
Oh.
All I did is move the cosine
so
over.
You're saying, the sine squared equals 1 minus cosine.
So sine of theta better be the square root of 1 minus cosine squared theta with the plus or a minus. How do we determine whether it's plus or minus? Quadrant 2. What does that tell us about sine? So it's the plus, not the minus. That's where the quadrant 2 comes in handy whenever that square root gets introduced.
But it's positive because
Quadrant 2, vertical.
yeah.
Okay. Well, hang on. So now I'm going to take this highlighted sign, right? And I'm just going to plug all that crap in. So now I've got tangent theta equals positive, though you don't have to write the positive, square root of 1 minus cosine squared theta times secant theta.
So you write in sine in terms of cosine?
Did read the problem and just don't say words. Oh, you were saying a second ago. Yeah, I did that, but why did I do that? I'm like one step away from being done. Secant's the opposite of cosine, so you know what I can do with this cosine right there? I can just jump in with the exact same thing, but write 1 minus 1 over secant theta squared times secant theta, and you're done. Now you've got tangent in terms of secant theta. Though you know darn well what I'd be doing. I'd be playing around with that square root and the common denominator stuff. And be like square root of secant of theta minus 1 over secant of theta. Wait, that's not true.
Wait a minute.
Secant squared of theta.
I don't get what we're doing. I thought the answer we already had the answer.
Well, we do, but look at the common denominators. That's too fun to pass up, yeah? No?
No, I'm good.
Well, I'm just saying, look at what's about that. We can cancel that secant out probably. I'm saying I see a secant on the bottom right here, secant squared right there, with a square root and a secant on the top over here.
I ran out of room, so that's why it's hard for me to.
I'm also quickly running out of room. Watch. This is what I'm saying. I'm saying, how else can you write 1? Well, yeah, but you could also write it secant squared of theta over secant squared of theta, yeah? Minus 1 over secant squared of theta times secant. Anybody see what's about to happen now?
So what's the answer?
Oh, this is fine. This is fine. Right? Because we got rid of everything that wasn't a secant. But what we're about to see is something really dope, like really cool. So this is going to be, I'll zoom out. Square root of secant squared theta minus 1 over secant squared theta times secant. You know what happens to that bottom one? It goes, you get the top, secant squared theta minus 1 over square root of secant squared theta times secant. Holy crap. Those cancel each
I
other.
don't know how I'm supposed to fit this.
And there's your answer. There's the super, super simple answer.
I don't know how I'm gonna fit all that. I don't have anywhere to fit that.
Do you need a piece of paper?
I'm just like I stopped at the tangent of equals
Right there?
yes, but I mean I could also move it a little bit.
Well, just go home. Here's what I would say. Is that a right answer? Yeah. Could you go home and practice manipulation to get to a simpler answer? Absolutely. But it's fun to practice. It's like a puzzle or something. Like just playing around with seeing what cancels, seeing what doesn't. like what I was saying is, as soon as I got there, I saw a secant on the outside and a square and a square root, and I was like, I know that square and that square root are going to do something cool. They have to.
I mean, I can fit it here.
I believe in you.
Um,
All right, what else we got? Problems.
24B.
24B. Oh, sorry.
I wasn't finished right.
Yeah, I got you. I'm going to freeze it, and then I'll go find the other one. Freeze. I can zoom it. Thank you. That's the better thing to do than just coming here and saying random numbers. 24B? Oh, shoot. Thank you. This is a good one, actually. And we should probably do C as well. We haven't done one like that, actually, all review. Like, I haven't done that any of the days that we've reviewed. Yeah, good call.
So, wait, but how does those two secants cancel if that's the square root of secant?
What's the square root of secant squared? You tell me. What's the square root of secant squared? What's the square root of x squared?
It's
No, don't write, think. Think. What's the square root of x squared?
square root of x squared is x.
What's the square root of secant squared?
Secant.
On the bottom or top for that specific problem.
It's on the bottom.
Boom. And you have one on the top too, E.
Yeah, but there's a 1.
What? What's the one?
When you do the square root.
Oh, you're talking about the
so
top?
the answer is secant. The square root is secant squared beta minus 1.
Yeah. That one has no bearing on that denominator. That numerator and denominator are two different things.
Okay.
They're just random numbers. That numerator and denominator are unrelated entirely. Okay, here's a good one. This is really important. This is probably more important than that last thing. Is sometimes they give you these things that don't look like they're perfect, but they kind of look pretty close to perfect. Like it's not 73. 73 give up because it's a calculator. Pi over 7, calculator. Things that look like they are kind of close to perfect are kind of close to perfect. So we rewrite them as two perfect things. So how can you rewrite 75 as two perfect things? 45 plus 30? But hold up, is there another way to rewrite it as two perfect things? 90 and 15? 90 and 15? Oh, 15 is not perfect. I guess that's it, huh? I thought there were two for some reason. No? Okay, I lied. Okay, well, that's it then. Oh, but that's our formula. This is our formula popping up into play, right? Sine. So here's my brain. Here's what I'm thinking. You don't have to do it my way, but this is how I try to remember the formulas for memorization's sake. I see sine. I know the signs stay the same because it's the first one. Second one, they change. So I'm going to go ahead and put this plus sign. That's what I do right away because I know the sign stays the same. For sines, the sign's the same. For cosine, flip it. Okay, now here's what I do. I write S, C, C, S.
For sine?
For both of the signs, it's S, C, C, S. And cosine's a little easier to remember because cosines are easy because it is cosine, and you just go cosine, cosine for both of them. And then you know what comes next because it's the two that are missing. Okay, and then what goes with that first S?
45.
45. What goes with that first C?
30.
And then I don't care which way you write them. I just care that you don't repeat. You cannot repeat. So we already have a sign of 45. So the 45 better go with the other thing now, right?
Yes.
It doesn't matter, honestly, which way you write the multiplication. It just matters that you don't repeat. All right, and then if I want to write this a little prettier, that's the way my brain looks at it and does that immediately because I don't want to memorize the long formula with the theta and mess up somewhere. I look at it and I do that right there. But if you want to write out the long formula because you're like an organized person, it would be the sine of the first thing times the cosine of the second thing plus the cosine of the first thing times the sine of the second thing. And those are all nice, neat numbers. We know all of those. Sine of 45? Root 2 over 2? Cosine of 30?
I think it's two
Root 3 2? Plus cosine of 45? Root 2 2 times sine of 30? 1/2. So we get root 6 over 4 plus root 2 over 4. No? Yes. Yes. Which is root 6 plus root 2 over 4. Multiply what? What do you mean by them?
Oh, I put the wrong side. Alright.
Breakfast burrito?
You can't combine them.
You can't combine them. You're right. Good call. What would it need to be to combine them? There is a operation that lets you combine them. What is that operation? Multiplication, you can combine them. That turns into square root of 12. Addition, I don't know nothing about it. Without a calculator. With a calculator, you can find a decimal, but why?
Combine until root 8.
No. You can't combine anything there at all. It's just the random properties of freaking exponents. Like, where's that exponent property thing? Or not exponents, radicals. But, oh, well, I'm frozen.
So basically, no, you
Okay, don't do that. That was a bad idea. Okay, but I want to do this radians one because this is a kind of tougher problem. So pi over 12 is not perfect, but it sounds super close to perfect. Actually, screw it. Let's not use radians.
I changed it.
Yeah. Let's convert. Is that what you were going to do too? Yeah, I think it's pretty common. Because everybody hates fractions. Everybody hates using fractions. Everybody hates adding fractions, subtracting fractions. So let's just say pi over 12. How do we convert that to degrees? 180 divided by pi. Always make those pi's cancel, right? If there's not a pi, you got to add one. Put it on the top. If there is a pi, you got to cancel one. Put it on the bottom. And that's going to be something like something that I don't know.
It's
Divided by
it would be
90 over 6?
It's actually it would be 15.
It's a smooth 15?
Yeah, because
Rats.
when you do long division. it's
Oh.
like-
That makes sense. We know where pi over 6 is. It's 30 degrees. It's half of it. I'm dumb. Okay. So 15 degrees. How can we make 15 out of two things that we know? The sine of 15 degrees equals the sine of 45 degrees minus 30 degrees. Yeah? Okay, so here we go. Boom. S, C, C, S, minus. Turns into minus. That's what I do. So I don't have to try to memorize the formula. And then I fill it in with 45, 30, 45, 30. Make sure nothing's repeating. Make sure the sign's the same. Make sure I started with what I started with. That's the important aspect of the sign thing, is that these two things match. The first two things match. You start with what you start with. So then we get, if I want to write it out better for the people that enjoy that and real math people who would be mad at me for writing it in that way, this is the better way of writing it. And by better, I mean realer. Boom, boom. That equals root 2 over 2 times 1/2.
It would be
No,
it would be square root of 3 over 2.
good catch. Minus times. Oh, this is gonna be the same thing, huh? Yeah, that makes sense. That actually makes a lot of sense. Because where the other one was the missing thing at the top-ish, this is the missing thing at the bottom-ish of the unit circle. So that's the main and only application of that top right thing, is for slightly imperfect terminal points. Yeah, if you want to take a picture of the board, that would be a good thing to add.
Can I take a picture?
Like, that's a type for that. This is area. This one is for nothing. That's for manipulation. That's not for anything. This is common. This happens all the time. And this one is for side, angle, side. And this one is for side, side. We have two sides. Doesn't matter which one they are. All right, we got plenty of time. What else we got? 18 and 19. Oh, sweet. These look fun. Okay, full disclosure.
These are the 18s and 19s, like the ones we were talking about. They are something. These are ones.
I'm just gonna do 18. 19 has the half angle identity again.
I have to use them. I have to use the third piece of food. These are the ones that have got me a lot.
Oh, good.
That I haven't, honestly, because I think it's the prime to me, but also I'm trying to remember all the formulas.
Oh
So.
my god, yeah.
I'll be fully honest. If you're doing something like 18, it's gonna be on the second half, and it's gonna be like half of the second half. Like it'll be you know how like the second half tests usually are like 2 problems or 3 problems total, and you get accumulate points. That's when something like this would pop up because this is a little longer. Though I don't think it should be too hard.
Can we go over 18 or something? Because this I need.
Yeah.
This is the thing that I'm still trying to.
There are lots of different ways to go about doing what we're doing here. All we have to do is prove that it's true. Right? Is that what it said to do? Prove it's true? It didn't say solve for x. That's all it says? That right there? Then I'd imagine it's like one of those things that says prove the identity.
Yeah. So these are the kind of problems that always get me a lot.
Okay.
Even when we were doing it together.
Well-
together a few weeks.
Yeah.
My goal is always to convert to sines and cosines. That's my goal. I don't know if that's helpful.
I mean, I know that sine 2x would have to equal like
Two sine cosine?
2 sine cosine. I mean, it's on the board, but
Let's make a note of it just because it's a good note to make. Okay.
What? So it'd be basically 2 sine x cosine x.
Okay. What else do we have going on? Secant squared? Is that true?
Wait. What?
I think it's 1 minus 10. You tell me. Look up secant squared identity. You're scaring me now. Oh, yeah. 10 squared plus x. So well, then we're done. Let's do it the short way and then the long way. If we just do that, we're pretty much done. So, this gives us 2 tangent of x over secant squared of x. Because
What? How is that secant?
1 plus tangent, you're allowed to use this, 1 plus tangent of x equals secant x squared. Which just comes from, like, if you don't like that, you don't have to like that. You can do it without it. You can say 1 plus sine squared over cosine squared equals 1 over, what is the secant cosine squared? Cross multiply, get cosine squared plus sine squared over cosine squared equals 1 over cosine squared. Use your identity, 1 over cosine squared equals 1 over cosine squared. Check.
But which one are we using for this question? Because you said that there are 2 ways.
That's a hard question to answer. Both. We just took a little shortcut.
Okay. So then I guess
This is just a note to prove the red thing. But if you don't remember the red thing, you don't have to. You'll get there just as easily. This is just a note to prove the red thing. No, this is just proving it. This is not to cancel out. This is to prove that this is this. Look, they equal the same thing, so we proved it. It's not to get anything. It's to prove that those two things are the same. So when we're allowed to use it here, how else can you write tangent? 2 sine of x over cosine of x all over secant squared of x. Well, that just spits that cosine down to the bottom, yeah?
Like,
For what?
I thought, but you see, on the question, the right side says 2 sine x cosine x.
Yeah, we're not done yet. We got to fix that secant.
And what was that note thing that we did?
The note was to get from 1 plus tangent squared to secant squared.
I'm lost.
Okay. Hold tight. Bear with me. Let me finish this, and then I'll go back and do it a different way. That's different.
All I was trying to put it into order. Then you said that it could equal secant squared x, and then you showed another thing, and then did that.
Right. So here we go. I think I lost a cosine somewhere. Oh, I didn't lose a cosine. This should be squared, yeah? Keep it, change it. Wait. Keep the top. Change the sign to multiplication. Flip the bottom. Flipping secant gives you cosine. One of them cancels. You're left with 2 sine cosine. There's your check mark.
I didn't write that.
Okay, if that is just wild, then here's the goal number 2 would be to not mess with any of those formulas and just change tangent to sine over cosine immediately and work it out. Slowly. Very, very slowly.
What's the x?
What x? Oh, that's keep, change, flip. I'm changing division to multiplication. That went right there. And I flipped.
Turns into cosine.
And I flipped. And when you flip secant, you get cosine, right? Keep, change, flip. Yeah, it's the fraction thing. That doesn't show up. So I'm not going to put it on there either. I'm not putting the half angle identities on there. I should, but this is hard enough. Right? Hang on, but I do want to see this real quick. That if you don't remember any identities, it's okay. You don't have every single identity is built from the foundational identity, that star one. Every single one. So watch this. Watch this. So this, let me copy this real quick. Here's what I would do. If you're struggling and you're like, I want to get this one right, and I'm already done with my test, take it 2, and you know what tangent turns into? Sine over cosine. Put big parentheses and do it slow. Big over sine. 1 plus sine of x squared over cosine of x squared equals 2 sine of x cosine of x. Is that okay? That's not too crazy.
Wait, that's
I'm just doing it differently. I'm showing you that if you don't remember any identities, any rules, anything, you can just convert the tangents to sines and cosines and slowly work your way through it. Really, really slowly. So the first thing I'm going to do is look at the bottom and say I want to put these two together. I want to put these 2 red ones together. So I'm going to leave the top alone. This is what I mean by slow, is do little steps at a time. Leave the top alone. Big old divide sign. And say, how do you combine those 2 things right there? Well, you turn the 1 into cosine squared plus cosine squared. Because can't 1 technically be anything over anything? So now we've got cosine squared of x over cosine squared of x plus sine squared of x over cosine squared of x. And what happens to that fraction right there? The denominator is the same, common denominator, so guess what we get to do? Right, cosine squared plus sine squared over just the denominator itself, cosine squared of x. Oh, there's a formula. Cosine squared plus sine squared is? No, 1. Sine plus cosine is 1 every time. So 2, big old parentheses, sine of x, cosine of x over 1 over cosine squared of x. Here's my keep. Here's my change. Here's my flip. 2 sine of x, cosine of x. Change, multiplication to, or division to multiplication. Flip 1 over cosine squared 2 cosine squared of x over 1. Keep, change, flip. And it breaks down into 2 sine of x over 1 times cosine of x, which is what you were looking for. It's good to practice. Go home and struggle through it. Go home and struggle through it. Start from scratch. Which part?
Off topic, but I didn't understand the video that you. I mean, I did understand it, but like it said test 3, right? Is that the right one?
I have no clue.
Okay. The video you posted.
It should have just been what I'm doing right now, which is me writing and recording the voice and questions. 26. No 26.
23.
We did it.
Oh wait, no, I already did 23.
Oh, I have a question. Can you go back to the
What?
real quick?
Yeah.
Yeah, so when you flipped
Keep.
cosine over 1,
Mm-hmm.
but if you left it as cosine, wouldn't it just be cosine if it's cosine over 1? How do you flip that? Wouldn't it be 1 over cosine?
I didn't flip cosine over 1. I didn't flip cosine. So the keep, change, flip, if I do it in better colors, is keep the top, the whole top. Flip, change the pink thing, which is just that big old line, the biggest line we have, and then flip the whole bottom.
Oh, so we're flipping. Okay, got
You're flipping the fraction, not flipping the cosine. It's already been flipped.
It's like another way to do it.
What do you mean another way?
Another way to do the same problem, or is that?
Yeah, no, this was me doing the problem, but without any formulas. The only formula I needed for that problem was tangent turns into sine over cosine. Now, it took 3 extra steps. I think there were like these 2 steps right here were extra. But technically, I did those 2 in my brain over here in the note. Like, it's the same 2 steps, just in the problem or outside of the problem. Yes.
Could you do maybe 2021?
Yes, what was yours?
How did you go from you said
Yeah.
like right when you have extra?
Uh-huh.
How do you go from cosine squared to cosine squared over to the root? How did you go from that?
You need to know that. The big stars. It's got 3 stars. This highlight is 1. That's the only thing that changed in those 2 sections. Yeah? Got you. I know it's such a big problem that it's hard to see the one little change each time, but that's what we did. Okay, which ones are you talking about?
20 to 22.
20 to 22.
Please. These ones look
Isn't this like kind of the same? It's a lot of like.
Yeah, 21. This one's probably not going to happen because it's so long. It's just it's the multiplication thing.
that we didn't go on.
1 minus cosine converted to sine.
How are we supposed to remember all these formulas
Yeah,
from
those-
Wednesday?
it doesn't look like we did ones like that.
No, we haven't.
So then they're not in the test.
No.
Yay!
Wait, none of those are in test?
No, they wouldn't be.
You're like.
The only one that looks kind of fun, honestly, is this 22. If I were to give you the formula for these 2 things, just because you can see it's real darn close to sine squared plus cosine squared. Like, it's really darn close.
You want to work that out.
Not really. Well, I'd rather spend the time. We don't have a lot of time.
Because he's not actually gonna put that.
Right. And we don't have a ton of time. If we had a ton of time, I do want to. It's not worth the time.
I have a question.
Yes.
One that you're like, you need to know this.
Oh, that's a good question.
Hey, let's stop this. Is gonna suck.
This triangle. This triangle is really important. Imagine this is changed to 45, 30, or 60. That would be something. So what is that? 12A.
So which.
Actually, that's a really good question. Here you go. Here's what we do. Turn to a blank page. That's a great question. One of these. I don't know which one. One of those.
Okay, just one.
One of these.
Okay.
Well, this is easy. You should freaking.
Yeah, I
That's a
know, so I
gimme.
was like, just one. Just
One of these. So 1, 2, 3, each get one. Oh, this is on a video too. So if you missed this, this part of the video is me telling you which ones are highlighting the ones that are important.
Oh, there's a lot of formulas.
Hang on. Shh. Something that looks pretty darn similar to this. I didn't skip them. The topics just come up later too. Like the 5 topic comes up in the one I just told you a second ago.
You already did 6. So.
No, I'm telling you as I look through this. Oh, this is really important. This is you taking the sine. And then, but here's the thing I would say with this one. This says find secant, right? Find all the things. Find all the things. There's only 6. Find all the things. I gave you 2 already. Flip sine, flip literally, no, that's easy. Yeah, I know. That's what I'm saying. I gave you 4. Find the other 2. So it's just draw a triangle and Pythag it out.
Okay.
9 for part 2 of the test. Like for the word problem part, the second half of the test. 11, but with easier numbers probably. Unless you want me to leave the hard numbers, but I would do a 3, 4, 5 triangle. Most likely. I'm not going to make... Okay, I know I said I was going to use the same numbers. I'm not going to make them harder. I might make them easier. Like that, you can do the exact same problem with a 3, 4, 5 triangle, and that gets easier. 12A.
No 12C?
Let's see. No. I mean, it's just 2 problems in one. It's literally just doing 2 of the same problems and subtracting them.
He doesn't want to go there.
I mean, it's just not, you don't use it in real life as much. The sines and the cosines you use it all the time. Of what? Oh, yeah, go ahead. Shh, y'all chill. Run out of time. And then we'll do one more problem once I flip through this whole thing. Oh, 16. 16 looks pretty good. And I don't know, we've probably done it, but 16 looks pretty good.
No, we did it.
We can do it in a second if we want to. 16 looks pretty darn good. One of these, I don't know which one. That's one of those formulas, the plus and minus formula. 25, test 3 and the final. I remember that problem like explicitly. I think it was a minus sign on the final, but that's just semantics. Like, no, it's crossed out. Oh, shoot. Whoops. 33. 34. 37. No, those are, we did them. We literally did those today. Oh, that's the whole thing. Okay. Those would be the most likely ones. Or one similar to them.
Oh, that's cool. I like it.
Okay. That's the most likely stuff. Let's hit a couple more, maybe 1 or 2 more, and then we can go. Also, if you come back, or if you want to, I'm not saying you have to or anything, but we'll just be working through similar problems from 12 to 2. So feel free to come in.
16.
Number 16. Okay, I'm just going to do it up here in this section. What does tangent turn into? Okay, then do it. What does sine turn into? Yeah, nothing. What does cosine turn into? Nothing. What does secant turn into? Okay. Anything happened yet that's nice? Sine squared, I guess?
Is that a proof question?
Yeah. Yes. Yeah, these should say prove, but if they don't, that's what it is. It'll say it on the test.
We get sine squared on the.
I guess just turn it into sine squared and see what happens. So we've got sine squared over cosine plus cosine equals 1 over cosine. Now what? No right answer, no wrong answer. Don't say it. No, You said multiply it by cosine. You were thinking something, but you didn't say it. I don't know what you mean by multiply it by cosine.
The other one? The one next to the cosine.
Oh, do we need to multiply cosine by cosine over cosine is what you were thinking. Yeah, that's a great answer. But you said it. And then you said the other one. No, you meant, do we need to multiply that cosine in the middle to get a common denominator? Well, no, right now all we're going to do is this. To get this common denominator. But I think it's so cool because that's good. But if you were a person who said, I want to move cosine over, you'll still get the right answer. Because that's what my brain would have moved cosine over. You don't have to. This is going to work. So now we get sine squared plus, that's cool, cosine squared over just one cosine, right? Because they pizzas, how pizzas work, right? One piece of pizza over one piece of pizza, 8's on the bottom of both of them. So you can mash them together and not make it 64. You didn't make 64 slices. 8 slices still. Oh, holy crap, we're pretty much done.
Doesn't the cosines on the sine over cosine cancel, or no?
I'm listening. What'd you say? Doesn't the what?
Oh no, they don't, because then it won't match.
Correct.
You have to do that to both sides.
No, because it's multiplying by 1. Yes, you do have to multiply both sides by 1. What you do to one side, you have to do the other side. But this is how I would write it there, and you're good. But you're right. Technically, in real life, what you do to one side, you have to do the other. So that rule doesn't go away. It didn't magically go away. There it is, right? And technically, we can't multiply it just to cosine. Technically, what we have to do is multiply it to the whole side. Just when we did our distribution, we left it as a 1 right here and turned it into something helpful right there. Like, you're right. Technically, you can't just go throwing stuff in the middle. If it's 1, you can't. No other number in the world. Well, I mean, that sine squared plus cosine squared just turns into 1. So 1 over cosine equals 1 over cosine. But I want to see this real quick. Because, what? Oh.
I got mixed up.
I thought I messed up. Because my brain didn't do that. That wasn't my brain's first thought. My brain's first thought was, let me move this cosine over. I don't know why. I was like, oh, I'll move that cosine over. Because I don't like having a fraction and a non-fraction. Mostly because I know a lot of students don't like combining fractions and not fractions. That's just a hard thing for a lot of kids. So I'm like, nah, I'm going to move that over so I don't even have that temptation. Equals 1 over cosine. Well, I've run into the same problem. That stinks. Yeah, I didn't know that was going to happen. But they're both cosines. So then you basically do the exact same thing, right? Which is multiply by cosine over cosine. You get 1 minus cosine squared over cosine. What is 1 minus cosine squared? Sine squared over cosine. Oh, look at that. You end up in the same spot. It's always going to end up in the same spot. There's no right way to do it. Heck, could you cross multiply? Watch this. This is fun. Multiply this side by cosine. What do you get on the right? 1, right? Cosine over cosine. Those cancel out. But what you do to one side, you have to do to the other side. Distribute that. What happens to that cosine? It cancels there, right? Because that cosine cancels. And cosine squared, sine squared plus cosine squared equals 1. That's fun. That's a fun way to do it. They're all right. There's no right answer. What?
Wait, so when we had that, did we multiply by cosine over cosine?
We did.
But wouldn't that make the number that does have wouldn't that make a cosine squared?
Yeah, it did right here. And sine squared plus cosine.
Yeah, not like on the bottom. Like if you're multiplying the top and bottom, and you have sine squared over cosine, wouldn't that make the bottom cosine be cosine squared?
You're talking about right here?
Yeah.
We didn't multiply this term by that. We only multiplied this term by that.
Oh.
Because we wanted a common denominator.
Understand.
Yes. We multiplied this term by 1. Just straight up 1. And we multiplied this term by 1. So technically, we multiplied every term by 1. Just one of them's helpful and the other 2 are normal. All right. Feel free to come back. I'll post this video and I'll post the other 2 hours from the other. Wait, don't leave yet. I got to. So, here we go. Anybody look through the review, practice it, and have What's up?
6.
Number 6 to get started. Number 6 is a good problem. All right, let's do this thing. Number 6 is one of those. I'm going to give you one little piece of information and you do the rest. Or you find the rest of it, like the things. All right. So what is the piece of information that they gave us? Let's see. They gave us the cosine of theta, right? Okay. They gave us the cosine of theta equals negative 1/5. So what is our job then? Yeah, it's not to find this. Our job is not to find that. That would be foolish to think that, oh, I can answer one type of one question. No, what is our job actually? Even further than that, the triangle is good. Like, the thing that you should be able to do that could answer every question in the world is to find what? The other, how many are there?
6.
There's 6 total. Right. So the triangle's good, but the triangle's only 3, right? 6, and the triangle helps us get there. We're going to draw the triangle. That's not wrong. But the goal of this whole thing is to get all 6 things, right? So there's 6 total things. There's sine, cosine, tangent, right? And then cosecant, secant, and cotangent. Okay? So before we even get started with that triangle, I think we know one. Which one do we know? Which kind of means that we know another one. Yeah, that's not bad, huh? Okay, I think it's triangle time, yeah. So what's cosine stand for? Oh, wait. That's a bad triangle. Yeah, they told us where it is. They told me where that triangle is, and I drew it in the quadrant 1. But they said, nah, that triangle is in quadrant 3. So it looks like that, probably. Where the cosine stands for. Cosine stands for adjacent over hypotenuse, which I guess it's worth saying the whole SOHCAHTOA thing. Sine stands for opposite over hypotenuse, and tangent stands for OA. So the cosine populates our thing with a negative 1 and a 5. Does that make sense? Does it make sense for the cosine to be a negative 1? Based on the direction we drew it for quadrant 3. That is the negative direction of x, right? And if cosine is kind of like the x, and that way is negative, then it makes total sense that this would be a negative 1. Which means your missing number is negative 1 squared plus, let's call it y for now, y squared equals 5 squared. So y equals root 24? Plus or minus root 24? Based on that triangle, we need to decide plus or minus. Why minus? Because it's going down. So throw a minus in front of it. I posit we can reduce 24. It's technically root 6 and root 4, which is technically negative 2 root 6. So now we've got negative 2 root 6. And the rest is history. Fill out your table of 6. What you get for your table of 6? Negative 2 root 6 over 5. 5 over negative 2 root 6. Negative 2 root, root 6 over 1? Negative 1. Oh, that's cool. That cancels out the negative signs. and 1 over 2 root 6. So then, but that's not actually the problem. Holy crap, we just did a whole lot of work to not even answer the problem. What's the problem asking? It's asking tangent, cotangent, plus cosecant. Well, we've got all those. The tangent is 2 root 6 over 1. The cotangent is 1 over 2 root 6. That's super nice. And the cosecant is 5 over negative 2 root 6. So we get something like 1 minus 5 over 2 root 6, which is the same thing as 1 minus 5 root 6 over 12. That was fun. Questions? Too fast at the end there? Reducing radicals is not fun, but it's important. Five? These notes are getting very long from the past 3 days. This is the last day of it, though, and then we'll switch to final exam. Oh, that's a good one. I like this one a lot. I just like them all, actually. I say that for every... I've realized I just say that every time I see a problem, because I'm like, oh, there's a little creative step in the middle. This is getting insane. Paste. A-boom. Okay. Express A and B in terms of theta. Well, how do you know the length of anything? What are the only formulas we have for this? What's the formula? There's not a lot of them that work, right? So how could you express A in terms of theta? We need A in it and we need theta in it. What formula has both those things? You said sine, and sine of theta is opposite over hypotenuse. And if that's theta, that makes this the opposite, this the hypotenuse, and this the adjacent, which makes it A over 24. Cut out the middleman so it doesn't look so ugly, and you get sine theta equals A over 24. Did it say it wanted theta in terms of A or A in terms of theta? I actually forgot. A in terms of theta? So you want A by itself, right? So how do you get A by itself? Not a trick, yeah, like not a trick question. And I think you're done. Is this a formula for A in terms of theta? That's it. There's nothing to solve. You can't. It's at, look, didn't it say find a formula or find an expression? Express the lengths of A and B in terms of theta. A is this. As soon as you know theta, you know A. Which means that by a parallel argument, B is going to be 24 cosine theta, and you're done. And you can work it out, but for the sake of time and getting through more problems, you can go and work that out. It's kind of fun. It's just fun because it's like, oh, in a generic sense, if you write hypotenuse times sine, you get y. If you write hypotenuse times cosine, you get x. This comes into play a lot with, if anybody did physics and kinematics, dynamics of physics, like with they'll always do like a cannonball getting fired and going like this. Like, well, the cannonball's x velocity is, or force, not velocity. Oh, you could do velocity with initial. you can say the initial velocity times the cosine of theta is how far fast it's moving to the left. And the initial velocity sine theta is how much it's going up. And we do that all the time. Break a vector into components. Pretty darn common, actually. Okay, got another one? 9. Yeah, that's fun. Also, if they have a highlight, like if we go through, see how 9's kind of highlighted? If we go through today and you see it being highlighted, maybe go home and practice it. I'm not saying the highlighted ones are the ones that are getting used in the test. But if I copy and paste one down here, and I'll post this too. I actually already posted this. This is live online. Yeah, if I copy and paste one, so like 5, I copy and paste it. You see a highlight? No. Is it still good to know? Yeah, it's still good to know. And yeah, it still actually plays into a lot of other problems. But if you were going home to study and you saw 9 and you saw 5 next to each other, you know which one's more important? 9, because it's highlighted right there. You see that? Just a little inside baseball for. All right. Sad day. This is a sad day. What? Yeah, it was, wasn't it? Oh wait, did y'all lose? Oh, y'all. Never mind. What? What? Oh. Where's TD? Wait, is he 9 o'clock? Is TD at 9 o'clock? Is there someone that sits behind back there? Okay, he's at 9 o'clock then. I was gonna say, where's he from? He's from the Netherlands? Yeah, that's what I thought.
He was literally screaming at me.
I thought he was from there. But I couldn't remember exactly if that's true. He didn't come to class today. He should have come to class. I was gonna ask him that same question. Okay, sorry. You got a ladder. It's leaning. It makes a triangle. Let's break this down and get rid of all the things that are confusing us and just draw the triangle. We've got 73 degrees. We've got 6 feet. Do we know anything else? That's the only, yes, that's super actually helpful. Oh, shoot. That's kind of nice just to solve the whole thing. Hey, I'm not even going to read the dang thing. Let's just solve the whole triangle. Not going to read the question. You can read it, but I'm not going to read it. I'm not reading the question. Zoom out. Let's just solve this triangle. Because that is a thing that happens a lot on the final exam. Not test 3, but the final exam. There's a triangle, solve it all. That happens tons. So let's just solve this whole triangle. So you said let's find that other angle first. So green angle is 90. Let's make it red then, and then we can do the colors good. So red angle should be 180 minus 90 minus 73. You're right, though. 17 degrees? Dope. Okay, we are missing 2 things only. We are missing 2 things and 2 things only. Let's do, which side do you want to do first? Blue side or green side? Here's blue side. I'll even call it blue. Here's green side. I'll call it green. Just for fun. Which side do you want to do first? Blue side? Because that's what the question is asking for. But, okay, blue side. We need a formula. I'm going to call this H for height. So H. Oh, wait. What's the formula, though? Cosine of 73 equals what? 6 over what? What? Oh, I shouldn't have called it H for height because that's confusing with hypotenuse. My brain was just thinking height. Let's call this T for tall. 6 over what? The hypotenuse, which would be H now, the new H. That's not true. That's not helpful, right? I mean, it solves for H. Let's go ahead and solve for H because we're here. It wasn't what we wanted, but this is now no longer blue side. This is now green side because that's, I guess, just what cosine does. Okay, so solve for H, and you get something like H. Oh, maybe. H equals 6 divided by the cosine of 73, which is, heck if I know. Calculator time. Go, go, go.
20.5.
20. Anybody else got this? I trust you, but you know, 2 people is great. 20.5? Oh, nice. Okay, so then let's do blue side now. And if that was cosine, what's probably the formula for blue side? Sine of $73 equals T over. Oh, I should have used tangent. Well, I mean, we know the hypotenuse now, though. 20.5. It doesn't matter. We're solving the whole thing. So now we've got T equals 20.5 sine 73, which is if I had to guess, I'd be like, say like 10, 9. Is it 9 or 10? 12? Point. That's fine. You'll get the same thing. What? Anybody else get 19.63?
Yeah.
Cool. Did you use tangent or sine? There you go. Look at that. 2 different ways to get the same thing. That's the best way to confirm. Probably feet. Is it feet? Yep, feet. And this would also be feet. So we've solved our whole thing. We've got 20.5 feet. That's how long the ladder is. We've got 19.63 feet. That's how tall the building is. It's pretty fun. So how high up the building does the ladder touch? The answer to the actual question would be 19.63 feet if we wanted to answer their question. I think it's more fun to see if you can solve the whole thing and know that you know what you're talking about. You said 14? Maybe. Maybe not. Ooh, that's fun. I don't think I've done this one yet. Like, over the past 3 days. Maybe. Again, yes, the question asks us to do a certain thing. I don't care about what the question asks us to do. I think it's beneficial every time to just solve the whole triangle. Like, genuinely. So, here we go. Oh, interesting. This is very interesting. We got to know some formulas here. They're on the board if you want to. Whoa. Oh, no. Oh, man. How used in course? Use again. Fixed mindset, growth mindset. Fixed mindset implies success or lack of. What? I'm so confused. FYS. Well, there were so many good formulas on the board, and now you just have to have them in your brain. What is the formula to be used? I don't think quadratic because it's not a parabola. No, that would be that's a what's it called? Pythagorean. I get it. They're both 3 syllables. I think we have to use the cosine one. It's called the law of cosines. And it kind of seems like the Pythagorean theorem as it gets started. It's like c squared equals a squared plus b squared. And then they throw this little weird hiccup. Minus 2a. Ooh. AB sine theta is area. This is missing side. 2ab cosine theta. Right? Don't take my word for it. Okay. I messed up earlier. I forgot the 2 earlier. So I was like, I think you forgot a 2. And I was like, yes, you're right. The one you were saying with the sign is area of any triangle. And that's area of any given triangle. Oh, which look, we're about to need. So might as well write it. Is 1/2 A, B, sine theta. Right? Yeah. Now, if that's a right triangle, sine theta just turns into 90 degrees, which turns into 1, and it just turns into 1/2 BH, or 1/2 AB. But that's not where we are now. So let's label these. What do we want to call what side, what angle? And actually, this wouldn't be theta. This would technically be the angle that's attached to C. So if we want to find the angle opposite the longest side, I'm going to call this one little c and this one big C. Cool? So 20 squared equals 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of, wait, what do I put for C? We don't have an angle there. What goes into C? What? And that's the only variable in the equation. So that's okay. It's just ugly that it's inside a cosine. We know at some point in this thing we're probably going to have to do the invert cosine or the arc cosine or the cosine to the -1 looking thing. So let's just hammer out the easier stuff and we'll get to the harder stuff later. 400, 81, 169 or 196? Facts? 18 times 13? Heck if I know. Oh, thank you. Times the cosine of something that we don't know. So 400 minus all that stuff you did already. 400 minus all that stuff. 400 minus 81 minus 169. I can't find my calculator. 150? That's a nice even number. Equals, I'm going to go slow, but yeah, we're about to divide. Divided by -234, so that cancels out, right? -150 divided by -234 is divided both by 2. You get 75 over ends in a 2. Middle things like 1. Oh, it doesn't end in a 2. Ends in a 7. 117. Is that right? My guess. I think it's right. Equals cosine of C. And this is the most important part of this whole question, actually. How do you get rid of that cosine? I always have to end up moving it a little bit over, right? Because you're going to write right on the inside of it, cosine to the -1. And that's going to take it out. And you're going to be left with C equals what you do to one side, you have to do to the other side. Cosine to the -1 of 75 over 117. That's what you write on your test. You don't solve it unless it's on the calculator portion, which is, bless you, the second half of your final. And then you could write the thing. And actually, to find this area, we're going to need that. So will somebody tell me what that is? Ah. Somebody do the arc cosine of that long fraction. Anybody got it? I have no clue. Good catch. Being dumb. Just keeps that negative sign through. Really smart catch. So -75 divided by what? 129? -75 divided by 117 is So you're saying 129 degrees? 0.79? I trust them. I trust 2 over 1. It's just keeping your decimals. Does that make sense? Does that make sense, like looking at that triangle and the size that they kind of drew it at? It looks like it could be 130 degrees. There's only one other thing that I really want to try to think about or resolve, and that is that the arc cosine actually has 2 answers that are the same. So if you think about cosines, where is the angle 130 at on the unit circle? It's like right here-ish, right? I don't have to be perfect, but it's like right there-ish, right? So that gives you this cosine right here, right? Where is the cosine the same? Down has the same cosine, doesn't it? Technically, that's the same cosine hitting those 2 points. I gotta find that angle. I gotta find that angle. So this angle was what? 130-ish? 129.86? So what does that make this missing angle? Like the reference angle or the other half? This is just thinking through the math behind this thing. That makes it 180 minus that, right? Like 50-ish, right? And you really don't have to do the math because we're going to see something happen. We're going to see something really interesting happen with that blue line. But I'm going to do the math just to be safe. 180 minus 129.86 is 50.14. So that red angle, that reference angle, is 50.14 degrees off the x-axis. So you know what that means about the blue angle? It's 50.14 degrees off the axis. So what makes the total angle then? If I were to make this pink now and go to this total angle, what is that total pink angle? Ish. Yeah. 180 plus 50.4 gives me 230.4. That was possible for my arc cosine. Like, this answer with no other information could be either of those answers. But now we've got to ask ourselves a question. If that's also an answer, is that possible to be the answer to the question they asked? Why is that not possible to be the question, the answer they asked? Because a triangle only has 180 to offer. So it's bad. It's not possible. You would have gotten it right had you not considered that, but that's there to consider. It's super interesting. It's like, even if it would have been 179, I would have been real hesitant to pick it because that doesn't look like, based on the side lengths, a triangle of angle 0.0001, 0.001 or whatever, or like 0.5, 0.5. Like, that triangle looks pretty normal style. Now, if your triangle looks like this, if it's like the wonkiest triangle in the world, which won't ever happen on a test, where your triangle looks like that, and it's got like side 23 and 22.99999, then maybe you might have an angle of like 179 or an angle of 0.5. But that's not ever happening on a test. Your tests are going to be pretty like generic 130. 130 is a great angle for a triangle. 179, 190, 230, not great. All right, last but not least, we got to do this area thing. So there's a couple different ways we can do the area. Actually, I think the easiest way is the new way. Yeah? I was going to say we could do it with that semi-perimeter thing, where you add up all the sides and then subtract each one. The semi-perimeter, anybody remember that formula? It's like the semi-perimeter is the perimeter divided by 2. Right? But then the area based on the semi-perimeter is the big square root of semi-perimeter minus A squared, semi-perimeter minus B squared, semi-perimeter minus C squared, and there's something else in there. I'm missing something.
There are no squares and there is an S for all those.
S minus 0 is the last. Yeah, you're right. No squares, S minus 0 is the way that I've memorized it back in the day. But you don't need that. we learned that, and then immediately after we were like, but this is better. Using the law of cosines and the law of sines, you can find every angle and every side, right? We could go law of sines this to find the other two sides, or angles, I mean. And you should go practice that. So now we can just say, okay, well, area technically is 1/2 AB sine C, where C is the middle angle, the included angle of those two. So we go A equals 1/2 9 13 sine 129.89, 0.86, and whatever that ends up being, we are content with. I will do it as well. Nine times 0.5 times 13. 44.91. It just unit squared, I guess, because it doesn't give you anything. Not too crazy. That's fun. I hadn't done that one yet. I like that. Number 17. 17. Going up, going up, going up. Heck yeah, we can do 17. That looks so fun. I see two ways to do 17. Just off the bat. I don't think either one of them is superior. Okay. Here we go. Did you try anything? You said you got stuck. Did you already start somewhere?
Yes.
What did you start by trying to do?
I make this to sine, cosine.
Everything in sines and cosines? That's what I would, yeah, that's how I would do it too. There's one other way I can kind of see to do, which is not worth it. Yeah, so sines and cosines. So you should have gotten like sine over cosine, big over 1 minus cosine equals, I'm going to put parentheses around this just because I'm a little trepidatious not to. 1 over sine, more parentheses, 1 plus 1 over cosine. Anybody have any questions so far? Please ask if you do. This is the important first step. Okay. Keep, change, flip, I suppose. One at a time. Just do one thing at a time. Keep the top fraction. Change division to multiplication. Flip the bottom. So you get sine of x, cosine of x, times 1 over 1 minus cosine of x. What's up? And then I'm going to leave all this the same for now. I'm not going to be a hero and try to do too much all at once. Now what? Multiply? I think we need to multiply the tops. What's sine times 1? Just sine? What's cosine times 1 minus cosine? Cosine of x minus cosine squared of x. That's interesting. Equals, do my distribution here. 1 over sine of x plus 1 over sine of x cosine of x. Now what? Can we get a common denominator over on the left? And by left, I mean right. So if I multiply this term, well, maybe. If I multiply this term right here by cosine, something pretty sweet happens. We end up with all the same stuff. That's all the same. But we get cosine of x plus 1 over sine cosine. That didn't really help us. You just cross multiply and get the heck out of here. That's what I want to do. Look, I'm getting the heck out of here. Let's cross multiply. You get the heck out of Dodge and be done. So if we cross multiply, we get sine squared of x cosine of x equals cosine of x plus 1 times cosine of x minus cosine squared of x. Oh, rats. We gotta do the FOIL. This is wild. Why did you pick such a hard problem? No, it's not hard. It's just you keep having to do the same stuff. You know what I'm saying? Is there a shortcut that we can make our lives easier? We could change cosine squared into 1 minus sine squared, but I don't think that helps us yet.
I think it's good that we foil it out.
Can you see it?
A little bit.
I see cosine. The only problem I don't like is the cosine cubed.
But it'll work out in the end.
Oh, sweet. Let's do it. Cosine times cosine is. I'll keep the color straight. I'll try to be careful, especially since I'm posting this and recording it. That's cosine squared, right? Green. Outside. Negative cosine cubed. Blue. Inside. Positive cosine of x. Oh, I see what you're saying. Wait, no, I don't. 1 times negative cosine is negative cosine squared. That one's nice, though. Oh, I do, because you're going to factor it out and divide, and it's gone. Facts. So now we've got sine squared of x, cosine of x, equals, 2 of those go away, equals negative cosine cubed x plus cosine x. Oh, shoot! There it is. Ding, ding, ding. Neil saw it way before me. Anybody see it without having to write it right now? What? You see it? There's one thing to do. There's just one thing to do, and then we're pretty much done. To super see it. Everybody will see it after the one more thing to do.
Change the sine squared to 1 minus cosine.
Oh, well, that's the... Yeah, you can do that. You can do that. I'm going to do this. You can do that. I'm going to factor out a cosine. It's the same thing. You're right. I'm going to factor out a cosine, so we end up with sine squared of x, cosine of x, equals cosine of x, right? There's that cosine. Big old brackets. Negative cosine squared of x plus 1. What's negative cosine squared of x plus 1? And look at what we ended up at. I didn't know we had it in the middle. There you go. That's the whole thing. I got a little scared in the middle too that we weren't. I mean, I knew we were going to end up there. As long as we didn't do bad math, you're good. It's just this is steps to go. This one.
You could have also on the left side, like what Reem suggested, we could have done the 1 minus cosine squared, and we would have got a cosine cube. Probably could have eliminated it. You probably would have done this.
You would have just done it cooler because you would have only had cosines to compare. All cosines is pretty cool because you know you're doing a good job. All right, what else we got? We can do one more and then we'll take a little break. Yo.
Can we do 13?
Yeah, absolutely. Sweet. This is a good one. Boop. 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 We have done. Did we do this one in this class or was that in a different class? We've done twice in this class? No, we have not.
Yes, that'll be the third time.
Oh, frick. We've already done it twice. Here, I'll do it real quick. We are about to take a break anyways. We'll just go through this real quick, make sure we review it. I didn't know that. I can't keep any of the classes straight. Area of a shaded region? Well, I guess not. Don't say shaded region. What's the area of a triangle? That's the better thing to say. Green triangle. How do you find the area of a triangle? 1/2. A, B, sine of the angle. So that means the area equals 1/2, 10, 10, because that other side's 10, right? Sine of 72. Sweet. That's area of the triangle. Now we got to say area of this pink region. Area of one of these things. I don't know what it's called, a sector, maybe. The area of the sector is theta over 360, because there's your proportion, right? Times pi r squared. Fight me if it's wrong, please. It's right? Okay, I'm also trying to remember these as well. I'm not ever going to say that I know everything and I have everything memorized perfectly. Pi 10 squared. There's that area. What do we do with those two areas? We go pink area minus green area, right? Also known as the sector area, which looks like a piece of pizza. Do pizza have curved crusts? They never seem to have curved crusts.
Yeah.
The crust of pizza is curvy?
Yes.
When I think of a piece of pizza, people always draw it like this.
That's not how it's. Well, I mean,
It doesn't seem curvy.
directly vertical. It's like slightly.
Yeah.
Pizza has curve. So a slice of pizza looks like this.
Oh, well, like the
Not
curve
like
was exactly.
That's a little thick crust.
See, because you gotta realize there's 8 slices around, right? So like, it's not gonna be.
I see.
I was like, are you trying to grasp the concept of like the slices sides being straight but the curve being?
Yeah, I know it comes from a circle, but I never. When I grab a piece of pizza, yeah, see, that's not what I'm thinking. Oh, the bigger the slice, the more you can see the curve. That makes sense because when you go to one of those New York places with the thin, yeah.
It's the whole
Okay, sorry. So we're doing slice minus triangle, and that's going to give you, and I'll make it red real quick because it was already red before. Oh, I can't see nothing. There you go. That's going to equal that red slice, right? So that's kind of the thought process behind that. Perimeter of the shaded region would be almost exactly the same. Oh, wait, no. The perimeter of the shaded region is dope. It'd be 10 plus, and you remember arc length is S equals R theta. So that means 10 times 72. So literally just be 10 times 10 plus 10 times 72 and you're done. There's your perimeter. Because S equals R theta. Where S is the curve, R is your radius, normal style, and theta is your angle. And so that would be the perimeter. Oh, that's not of the shaded region. My bad. Wait, I think we messed that up last time I did this problem. I think we did perimeter, which is fine. It's a different problem. I think we did perimeter of the piece of pizza, not of the shaded region. No, but it's okay. It's just a different problem. Perimeter of the shaded region, we would have to find the one missing side. Right now I'm drawing it as green. And we'd probably use law of sines to find that side.
To find the little bit shaded region.
Oh, we worked to find that side? Using like law of sines, law of cosines, like triangle rules? Okay. Oh, is it? Okay, so we did do it. Yeah, because that's about right. That sounds like About right. 11.75-ish. So I was wrong about that. That was the area of the slice of pizza, which I could see myself asking on a test. The area of the red slice would be using the law of sines to find that green side, and then adding the r theta, which is 10 times 72 times pi over 180 to convert it from radians to degrees, or from degrees to radians. But also, it's up here above and much cleaner. If you scroll up, it's somewhere, right? And if you go back and there's a video posted online already. I think I posted it over the weekend. Yeah. Oh yeah. There's a pretty version of it right there. That's way prettier if you want to take a picture of that. Oh yeah, because we did the area of a sector slice. Labeled it, convert to radians, put star, 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 make sure you use radians. Oh no, see here's one. This is what I was talking about. This is where the second time I did it. I'm gonna change this on the notes. This is the perimeter of the slice of pizza. And then the first time we did it the right way. That's cool though that we can do two different problems with the same thing. It must be because I shaded in so much shading that I didn't see where their original shaded region was. Okay. Any more quick ones real quick or no? Like everybody good with the this is a question. Everybody good with 1 and 2? Converting from radians to degrees to radians. Radians to degrees times pi over 180. Degrees to radians times 180 over pi. I don't know why I wrote pi. Really? 2b? Oh, negative 1.3 times 180 over pi. If you're not on calculator. If you're not on calculator, yeah. If you want to be super extra, you can go 1.3, 180, and then go like 0, 4, 2, 5, 0, 180 over 0, 4, 3, 1. You know what I'm talking, like dropping this down, 34. If you want to be extra, you can go negative 34 over pi. But if you wrote that, I'd give full credit. But you can also do it if you want to. Like, if you have extra time on the test, might as well. It's 2-digit multiplication. You can do that. It's not fun, but I don't like doing it. All right, we'll take a little break, 9 minutes. And pause this. Start recording. All right. Anybody look at one or find one that's hard? All of them are hard, but. Number 8.
Well, I was just looking at it.
Oh. It's okay. Excuse me. 33. Yes, and it's circled, so that's even better. Good ask. All right. So 33 looks like one where they're just straight up pretty much the only step of this one is knowing that formula. Knowing that double angle identity or whatever it's called. It's called double angle identity. So that double angle identity turns this red part into what? 2 sine theta minus cosine theta equals 0. Any ideas? Oh, I know. It's like we're done. I think so. Let's take them out. A boom. A boom. A boom. A boom. What's that called right there? What is that green thing called? Is important. Common factor? Or some people just call it factoring. But yes. And it's kind of like the reverse of something. What is that the reverse of? Yeah, it's like reverse distribution, right? It is factoring. It's called factoring. But I like to think of it too as like reverse distribution. If you want to check whether you did a good common factor, just distribute it, see if you end up in the same spot. Okay, well now what? Now we've got the whole purpose of factoring. What's the whole purpose of factoring? What? Yeah. Those are each individual factors that equal 0, right? So just like if you would have had, like, watch this. This is kind of a cool way to think about this problem, is if you would have had 2x, y, minus y equals 0, and then you factored out your y, you know darn well what you're doing right there. Once you get to that step, everybody knows what you're doing, right? You're saying, oh, look, there's a 0 and a 1/2, we're done. A lot of people would say that, right? Actually, it'd be more common if those are both x's with an x squared. But everybody sees that, right? So it's the same thing over here. Like, oh, we're done. The green side gives me cosine theta equals 0. And the red side gives me 2 sine theta minus 1 equals 0. And where's the cosine of theta equal to 0? You gotta think about that unit circle. All right, pi over 2. And did this problem give us restrictions or not? I didn't look. I should have looked first.
Yeah.
Where did it say those restrictions were for?
0 to 2 pi.
Okay, so if it gives you restrictions from 0 to 2 pi, super important that you like just write it and you're done, right? There's your answer. Yay, we're done. Whoops. Yay, we're done. But if they don't give you restrictions, you remember what we added to both of those? And usually they have the word all. It says find all solutions. Oh, I'll write that. If they were to say find all solutions, it's the exact same answers. You don't change anything. You just add 2 pi k, where k is an integer. This is not what this question asks. It's just good to note. Like, oh yeah, we could also do that. We could also find all solutions. All right, let's hop over to this red guy. 2 sine theta equals 1 sine theta equals 1/2 theta equals, whoever's got it memorized the best. Man. You gotta memorize that unit circle. And 5 pi over 6. Love it. You could add 2 pi over k if they said all. You don't have to. You don't have to for this problem. But if they said all, excuse me, I'm so sorry. It would be pi over 6 plus 2 pi k. That's a bad plus. And 5 pi over 6 plus 2 pi k. Love it. That's a great question. That is a good one. That one is like, yes, that will be there. It might have a different number on the outside, but I will tell you the factoring out thing will be there. It might not be like set equal to 0. Maybe it's minus 1 or something. I don't know. Maybe it gives you, instead of cosine of theta equals 0, it's like cosine of theta ends up being pi over 2. Or you know what I mean? Like 1. So that's at the top. Or negative. I don't know. We'll see. But it'll be easy things, and it'll be one factor. That's just a one factor with easy unit circle values. I can't wait. That's a good problem. All right, what else we got? Problem wise. Number 3. Dude, yes, actually. We did that last class, and I forgot that we hadn't done that yet. We'll do 2 of these. Let's do one that's actually, heck. Let's go crazy. So this is like the situation. This is the situation where it's almost perfect, but it's not. Right? Like it's almost a good number. Oh wait, no, it's not. This is easy. This is normal. These are good numbers. 5 pi over 3 is on the unit circle, right? I believe 5 pi over 3 is on the unit circle. Is it not?
Yeah.
What? Oh, it's in quadrant 4. Yes. Well, let's start with A and just work our way down. How else can you write sine of 405? Sine of 405 minus 360, which is the sine of 45, which is root 2 over 2. Negative 150. Tangent of negative 150 plus 360. That's the tangent of 1/3. Wait, 210. Thank you. Heck, I don't know where 210 is. 180 plus 30. So tangent. So that is this one right here. Right? Which means the sine is negative 1/2. And the cosine is negative root 3 over 2. So you end up with positive 1 over root 3. Root 3 over 3. I believe. If I didn't make any algebra mistakes. 5 pi over 3. Heck if I know. Here's 1 pi over 3. Here's 2 pi over 3. Here's 3 pi over 3. Here's 4 pi over 3. There's 5 pi over 3. So secant is kind of like, it's not kind of like, actually that's dumb of me to say. Secant is 1 over the cosine of 5 pi over 3. What's the cosine of 5 pi over 3 based on that angle I just drew? Looks like negative root 3 over 2. Flip it. You get negative root 2 over 3. I shouldn't put that equal there. I should put that down there. And then put this. Just for good writingness. All right. Which one? I'll skip D. Let you do D. What? What? Is that wrong? Oh my, that's all wrong. Why did you yell? That's 5 pi over 6, right? Let's just pretend like that's what we were doing. Why didn't you yell? You should have yelled like, hey, you're doing 5 pi over 6. And just running with it. 5 pi over 3 would have been pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. That one right there, the tall one. So it would have been the sine. We're doing cosine, so negative 1/2, so positive, just 2. negative 2. Positive 2, because it's in the plus side now. Okay, well, side note, secant of 5 pi over 3 is 2. But just practice those. Those are good ones. I thought we were doing a plusy one, which is actually super important too. I'm gonna pick that one for us for right now, because it's good to refresh your brain. This kind right here. These two. Okay, so these aren't perfect, but they look almost perfect, right? If you see the sine of 19, guess what you do? What are you going to do if you see the sine of 19? Nothing. You're going to calculate it or nothing, right? You're done. We can't even get close. But if you see the sine of like 15 or like 35 or like 40 or like those things that look good but they're not perfect, 75 is an example of one of them, then it's kind of like, okay, well, let me try something, right? Let me try to rewrite this as the sine of two things added or subtracted that are good things. So what two good things add or subtract to get 75? I would say 30 and 45. And then we apply the formula from there. The formula kind of says, for sine, what do you do? For sine, you go sine, cosine, cosine, sine, plus, then you fill it in and you go 30, 45, 30, 45. And if you're not a shorthand person, that's okay. I'm a shorthand person. You don't have to be. You can write sine of 30 times cosine of 45 plus cosine of 30 times sine of 45 equals. And then you know those in your heart because you have your unit circle memorized so well. The sine of 30 is 1/2. The cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. And the sine of 45 is root 2 over 2. And if you add and multiply all those things, you get root 2 over 4 plus root 6 over 4, which is just root 2 plus root 6 over 4. Happy camper. That's really important. Sine of 19, done. Can't do. Sine of 75, possible. Super possible. Note for the radians, it's probably worth, if you get to the radians, just convert them to degrees. Unless you love adding and subtracting fractions, just convert the radians to degrees and solve the problem. Repeat that. What'd you say? I heard cosine A sine.
Yeah, so for 24A.
I gotta go see it. 24?
Yes,
A?
So,
Oh, you're uncombining it.
yeah, that's reason. Like, but how do we, like...
Plus? Plus means plus. Sine cosine means sine. So sine of 8 plus 22?
So we just write
Sine.
30?
No. What's sine 30?
22. No, 5 or 6. Yeah. Right. 5 or 6.
Sine of 30 is not pi over 6. 30 itself is pi over 6. Sine of 30 is 1/2. If you want to convert back and forth to radians, you can. Like, whatever you're working on, just be like, I like radians better. I'm going to go over there. Convertible. I would never be mad about that. Okay, what else? This is a good review time to... Gee golly, go find a problem. Are you looking at the review? Luis. He's not even listening. Is he looking at the review on his phone? Are you looking at the review on your phone?
Yeah.
Actually?
Yeah.
Oh, I thought. Good job. I thought I gotcha. TikTok.
Oh, it's like,
Okay. What else? 12E. Let's see. Oh, sweet. Yes. I would love to. Ooh. So there's some laws. There's two laws, really. The law of cosines and the law of sines. What's the law of cosines say? Oh, crap. Law of sines? Gotta know these two. We gotta know. These are the only two things to set up memorize, really. This is so important. This is so important. The cosine one looks like it looks like the Pythagorean theorem. Where c squared equals minus 2ab cosine of c. So let's call these two c. Okay. So we're going to go 9 squared equals what do we got? We got 6 squared plus 8 squared minus 2, 6, 8 cosine theta. Or C, whatever you want to call it. Wait a second. We don't know theta. That's what we're looking for. It's the only variable. That's good. 81, 36, 64. 48 times 2 is above my pay grade. 96. Is that true? 12 times 8 is 96? Times table people. So 81 minus 36 minus... Wait, that's a negative number. I guess that's okay. 81 minus 36 minus 64. $81 minus 30 minus 64. Yeah, I just got that too. Negative 19 equals negative 96 cosine theta. So divide those two numbers, yeah? Divide by negative 96. Divide by negative 96, you get something like 0.198 equals the cosine of theta. How do we get rid of that cosine? Arc cosine it, yeah? Arc cosine of 0.198. It's going to be something like 78.58 degrees. Let's not stop there, though. Let's solve the whole triangle. Let's like what? What? No, not usually. When on the test, more so on the final, because I've seen it, but potentially on this test as well. Instead of just giving you like 3 different triangles, like on this thing, just give you one triangle and say solve the whole thing. When you say solve the whole thing, you just mean find all 3 sides and all 3 angles. That's it. So that green angle right there is 78.58. We don't have to do the hard thing again, though. We can do the easy thing now. The law of sines, which says that the green one, the sine of 78.58 divided by 9, because that's opposite of it, better equal 8 underneath, let's call this freaking alpha, because they already said theta, over the sine of alpha. And that means that alpha better be 8 over 9 sine 78.58 all arc sined. Yeah, I got to get my calculator out for that one. That's a tough one without a calculator. So the sine of 78.58 times 8 divided by 9 is What? So, oh, I haven't arc signed yet. Is 60.61. Is anybody else tracking? I know we're doing big numbers. Don't want to lead everybody astray though. And I want to make sure it's right before I post it online. Yes? Same. Okay, sweet. So now you could do the law of signs again, but you don't have to. You tell me why we don't have to do that. Yeah, that's a little easier to me at least. I think. I mean, it's honestly not that much. No, that's easier than doing two signs. So then you would do 180 minus 60.61 minus 78.58. Doesn't matter which order you do it in. And you would get something like 180 minus 60.61 minus, that's plus sign, 78.58, 40.81 degrees. You add all those up. You should call that beta. 40.81. You should get 180. And that is a completely solved triangle. It's got all three sides and all three angles. Now finding the area should be pretty easy. You could use any side and their included angle. Finding the perimeter is pretty easy. I guess those are really the only things we do with triangles. What'd you say? C? Same, like in the same section? Let me see. Did we not do that already? Or we did? Just do it again? Maybe we didn't do it yet. Yeah, I would definitely do it then. Alright, C is pretty darn similar. Instead of we could solve the whole triangle, but instead of doing it, let's just solve the thing they're looking for. That way we can get practice on other stuff too. But you could definitely go home and say, I'm going to just solve all of these triangles. Like both parts of this triangle. All right. So, for starters, I see two completely different triangles in here. Let's call one red triangle. And one blue triangle. Two completely different triangles. I'm going to hop over here and draw them. Whoa, come on now. All right. There we go. All right, blue triangle. We've got 50. We've got 28 degrees. And I think that's it. Red triangle. We've got 50, 20 degrees, and I think that's it. What? That's helpful. So what do we want to find? We probably want to find this side. Let's call it A. And this side, let's call it B. That'd be sweet if we could find those two sides. Is there a formula that lets us find those sides? Is there some formula that lets you take an angle, call it theta, and use the opposite side? Well, that's not the opposite side. And use the adjacent side and the opposite side. Yes. The tangent of 28 better be equal to what? A over 50? Which means that A equals 50 tangent 28. which means that. Oh, you got it already? What'd you say?
26.15.
Okay. Well, that's just this tall side. We want this little X, this highlighted section X right here. Do the same thing over here for this side, and then just subtract them. Yeah. So this one would be 50 tangent 20. And then we're going to subtract blue minus red. So really, you want to be like super cool about it. Technically, you could just do this right here. 50 tangent 28 minus 50 tangent 20. So we're going to be really cool about it. You could be like 50 tangent 28 minus tangent 20. And you can't be cooler than that, but it's pretty nifty to do non-calculator wise. Calculator, you just plug it all in and you're done. That probably wouldn't be on the non-calculator section. It'd probably be easy numbers like 30 and 60. And if it's 30, 60, you just figure out what they are and just reduce it down. Having a good time out there. All right, we can do a couple more. We can definitely power through a couple more. What you thinking? You're not leaving early, dang it, so solve these problems. 15? Let me look. I don't remember. Have we done this? Because I have another class, so I don't know for sure. Have we done this air balloon problem in here? No? Okay, we can do it. How high is the balloon above the ground? Yeah, this is good. I just don't know how to copy and make it. I don't want to ruin it. I don't want to lose all this stuff. Watch this. I'm going to redraw this thing. Boom. 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 100. 75 degrees. 85 degrees. That's going to be a right angle. And that's all the info they gave us. They called this H for us. Okay. There's our problem. Sorry for the messiness of it, but I didn't want to delete it. There's work up there that you can do. We'll do the same exact work down here. What? No. How do you copy? There we go. What? I'm so confused. Sorry. I don't know how computers work. There it is. Okay, so we've got this air balloon, and it's floating way up there, and it's tied to a line. That red line is like the line. And here's the balloon. Bad at drawing balloons. Okay. So the question is, how high is the balloon off the ground? Wait, is that true? I gotta look at this picture now. Why are there two lines? Is it attached to two lines? Sorry, gotta find it. What problem number was this? I forgot.
15.
Thank you. 15. Oh, yeah, it's just attached to two lines. That's weird. Okay. Okay, so we got this balloon tied to two lines, and it's asking us how tall it is off the ground. And all they've really given us is like one side, which is this 100 it's tethered to the ground 100 feet apart. And so they're really just saying, hey, can we solve like a bunch of different triangle stuff to get to this one triangle in the bottom corner? Like, can we get to this blue? Please stop. Can we get to this blue triangle right here from all the information they've given us? So let's see. Let's just see 85, 90. That's all we know. A random H. Okay, that's not like super helpful. Can we solve that right there? That blue triangle, can we solve that? No, we don't have it. Yeah, we need at least one side. If we had one side, any side, we could solve it. Any side. Not even two. Just one side, we could solve it. We don't. That sucks. So let's hop over to this red triangle and see. Even though it's not as pretty of a triangle, mostly because it's not right, this is kind of cool. Because we have one side, so we can solve it. But we just got to figure out how can we solve it with only one side. There's something hidden in the problem that they didn't tell us, but they showed us, and I can look at this problem and know about that red triangle.
Oh, huh. Yeah.
You said, were you talking about this right here? That green thing is 180 minus 85. Why 180? Straight lines are 180. See, this is kind of weird. I always saw this, and I think it's interesting. Why are straight lines 180, but also triangles are 180? But circles are 360. Triangles have 3 lines. Circles have 1 line. Straight lines are 180. You know what I'm saying? I think it's just a fun little thought experiment. You can play with it and see why by doing the outside exterior angles of each triangle. But it is interesting. That 180 is a line, but also a triangle. Isn't that fun?
Yeah, like that's a good point. I never thought about that.
They're two different 180s happening. One's a angle, and one's a sum of 3 angles. What? I know. All right, so yeah, that's a thought experiment for another time. That has nothing to do with this, but you're right. So that makes this 95 or 105? 95 degrees? Holy crap, you know what we could also find then? Just for fun. We don't actually need it, but just for fun, I'm going to hop up here and be like, 180 minus 75 minus 95. Very small. Is it 10? 105. Yep. Oh, holy crap. We don't need to do the hard one. We can do the easy one. How can we set up the easy one to get our answer? Yeah, which one? Obviously, the 100's got to be in there. So let's make it pink. The 100 is pink. What number goes with the 100? Oh, it's down here too. Boop, boop. Oh, I should have done it down here. It would have been cleaner. Here we go. Here's our 95. Here's our 10. So the sign of 10 goes with 100. And what are we setting that equal to? Well, it depends which line you want, right? Do we want this one? Or do we want this one? I think we want this one because it's the exact same as that, right? See how those triangles are touching? So what I'm going to say is this is the sine of 75 over, and we got to call that something. I don't care what we call it. Let's call it, I don't know. What do you want to call it? Z? Z's fun. Z never gets used. There's Z on all those problems. It's all the same. So technically, Z equals, be careful here, 100 sine 75 divided by sine 10, which is the calculator problem. It's 75, 30, and 40? Oh, 35 and 30 and 45. But sine 10 is not. So what'd you say? 556.24. Okay. But that's Z. That's cool, but that's not what we wanted to get in the end of this day. We wanted that height, right? So we're going to hop over back to this triangle blue, and we're going to say, is there a thing that relates an angle, call it theta, with its opposite side and its hypotenuse? What's that thing called? Sine of 85 better equal h over 55.24. So h equals what? Yeah, I don't know why I did that. Thank you. Thank you so much. And that is going to be a big old number because sine of 85 is super duper close to sine of 90. Sine of 85 is almost sine of 90. Sine of 90 is 1. So I can tell you right now, it's going to be close. It's going to be like 554 or something. What? That sounds about right. 553.88. I would believe that. Those two numbers are so close to each other because sine of 85 is almost sine of 90. Sine of 90 is 1. That's a super small angle. That makes sense in a triangle world. If this red triangle has an angle of 10, the two long lines better be super close, right? Because the closer they get to 0, the exact lines they are. The further they get from 0, the more different they are. I'll zoom out so you can take a picture if you need to. There's also posted up above, and I'm also going to post this. Like right now, it's already online. So if I just like save this, it should update online. So there you go. It's also online. All right. I'm check roll. Call it a day. If you have more questions, I'm happy to answer them. I do have a little meeting at 2, which stinks, but where's my minimize button? Boop, boop.